Good. Let's get this party started. So, hello and welcome to BSDCan 2026. This is our 23rd BSDCan, and as Dan said years ago, welcome home. Welcome home. This, like any successful BSD entity, we hand off leadership. First it was Dan Langell, then it was Michael Lucas, and now you have me. And in 2028, it can be one of you. Over the past 2 decades, BSDCan has become an essential part of the BSD ecosystem. And we have worked to establish a sustainable team with backups for just-in-case incidents. And with that team, we have built a path of experienced people who then train new volunteers who will help us build the future we want. And this year, we bring you 30 talks. We have 30 talks. We have 3 BOF sessions. We have a series of lightning talks, which I will get back to later. But the most important thing is we have the people. In this room, we have authors of the books that we read, the blogs that we follow, and the software that brought us here today. This conference works very hard to keep itself affordable and keep itself affordable while allowing you to rub shoulders with giants of this industry. We have people here who have written software that is running in space. We have people here who wrote the software that streams 1/3 of the internet during primetime viewing hours. We have people here who write pretty accurate time software while doing it securely. Yeah, we'll get to that later. But none of that would be possible without our sponsors and our team who sponsor us with both their time and talent. So let's take a minute to thank them properly. First, we'll go with our gold sponsors. Apple. ARM. Our silver sponsors, Antithesis and Free BSD Foundation. Also silver sponsors, ISC and Netflix. And of course, NetApp and Tarsnap, who helpfully have logos about the same size. And now, for bronze sponsors, we have Clara Systems, NetBSD Foundation, OpenSense, and a new sponsor and contributor in many other ways, Saltant Solutions. Now, we also have our post-conference reception sponsor, Tilted Windmill Press. Yeah. Now, unfortunately, Michael cannot be here with us today, but I know many of us here miss him, and if you will permit me to be silly just for a minute, I would like to call out a 3, 2, 1 and have us all shout, "Hi, Michael," because I know he's watching at home. So 3, 2, 1. Hi, Michael! Yes. And also we have travel sponsors, Netscommune and OpenBSD Amsterdam. Here's something. Caffeine has been sponsored. Good news. And here's something that's close to my heart. For if you've been enjoying the streams over the years, we have Scale Engine to thank. They've been our streaming CDN for the last 10 years. So, and I would be remiss if I did not thank the most talented group of people I've ever had the privilege of working with. So hold your applause for the end as I thank Colin Percival, Alan Jude, Melissa Muth, Andrew Fengler, Adam Thompson, Albert Deng, Michael Williams, Michael W. Lucas, Diane Bruce, Michael Dexter, Graham Percival, John O'Brien, and lastly, and at least and lastly, John Hickson. And of course, to Dan. He started this, yes. You started this more than 20 years ago, and we cannot thank you enough for making this home for us. We hope we do you proud. So, as a refresher, for those of you who may have forgotten, and any of the newcomers who didn't make it to the newcomer session yesterday, if you have any questions, please, chances are it's been covered over on the website. If it hasn't, maybe, hopefully, in this talk. If not, you can always email us at info@bsd.org. And you guys like these lanyards? They're kind of fancy, huh? If you want one, you can have one next year by joining the organization committee. We are always open to new members. But more importantly, if you have a situation that you need to have attended to, if you're having a problem, grab somebody with one of these lanyards. We are all organization members, and we are here to help. So there's some responsibility that comes with the privilege of the fancy lanyards. But yeah, if you get a hold of one of us, we'll get you the help you need, okay? So additional resources. In this building, we have a couple of spots. We actually have something we started, I think, last year, but we've been continuing it because it got good reviews. We have a quiet room in 1130. So if you need to kind of consolidate your thoughts, work on your, consolidate your talk slides, maybe consolidate yourself, 1130 is the place to go. It's open Saturday and Sunday from 9 to 4:45. We also have say again?
Friday and Saturday. We're not here Sunday.
Yeah, I said Sunday? Oh, my apologies. Friday and Saturday. See, it goes so fast that I'm already a day ahead of myself. But yeah, Friday and Saturday, and where you go. It's a lot of people have been enjoying it. And then if you also just need to make a quiet phone call or just get away from people for a minute, there's a nice lounge up on the second floor. It's the stairs right behind the registration desk. Okay, and now we also have, if you go out that door, there's a water fountain with a bottle refiller, and believe it or not, a working payphone that you can use a card in. I tested it, it works. Now, last thing, carrying a box. It is a BSDCan tradition that Dan would say all the time is you haven't been to BSDCan until you've carried a box. And while that's a really talented way to induce people into free labor, it's also a really good way to meet your community. And so there's somebody in one of these during this conference will probably go out into the hallway and like, hey, I need a couple of people, we need to do this. You go, you help, and you help your community. And if you want to continue to help your community, we also have another way. You can give a lightning talk. That's me returning to it. So if you have an idea you're passionate about, you'd like to share, we have 30 minutes of time that we're going to split up. Whoa, okay. 30 minutes of time, we're going to split up into like 5-ish minutes of talk time for each of you. You have to have your idea, and you have to email it to lightning@bsdcan.org, and you need to give your name and your talk idea. You have to get that in by 5 today, and then tomorrow morning you have to have the slides by 9 o'clock in the morning. And if that's the case, we'll get you your slot. And they're filling up. I've already seen a couple of people have already jumped in and are looking to get some talks in. So the deadline is 5 p.m. today to sign up. First come, first serve. Idea this evening, slides by tomorrow morning. Today, yeah. And in fact, we had Anubis give a lightning talk last year. And like that, who here has gone to a website and had that quick loading page, And that was just a lightning talk last year. So don't forget the Hacker Lounge. It's in the residence hall, the first floor in U90. It's very handy. It's a really good social circle for people to to hang out, hack on stuff, and get things done. It is open late. Could you do us a favor and just tidy up after yourselves? Because we don't want to, well, we want to come back here. So hang on to your stuff, or it could show up in an auction. And your buddies might bid against you. It has happened. Yeah, it would totally. Yeah, you know these people. You've been working with them. You know they will do that. But it's a lot of fun. So our reception is at Lux Bistro. It's at here's 47. Here's the QR code for it if you want, and we'll put it out on announce, obviously, and. And of course, at the end of the conference, just follow the crowd and they'll all kind of make their way. It's down in the Byward Market area, and they have an information number, email address, and more importantly, there's the phone number. Good to move forward? Cool. And of course, we have, if you want to, stay in contact with us when you're not here, there's always. You can subscribe to the mailing list BSDCan Announce, which is available on the website. And here is the volunteer mailing list. So now, that's about it. Remember to have fun and wear your, do yourself a favor, wear your badges when you're going for the food. Just keeps things running smoother. And now, there's this other thing happening. It's a BSD thing happening in the near future.
Yeah. If you want to come to Brussels and hang out with the European part of the BSD community, here's your chance. BSDCan is in Brussels, September 9th to 13th. Our call for paper ends tomorrow. So, if you want to submit a BOF or talk or tutorial, please do so right now. And by I think it closes at midnight European time zone. So please just get on there, follow that link, events.eurbsdcon.org/2026. Get on there, start typing, and we'll see you in Brussels.
And remember to have fun.
Are you able to hear me? Is it audible? Is it audible? Okay. Yep. Hello, everyone. Good morning, and happy National FreeBS Day as well. So today I'm going to give a talk on running stock FreeBSD on Windows subsystem for Linux 2. Quick intro. I am Balaji Shankar. I'm from Chennai, India. I've been using FreeBSD in my free time since my college days. It's like around 20 years now. And yeah, I work in a financial services company. And a quick recap on why I started this project, this personal project. It's not a sponsor project, but why do FreeBSD on Windows subsystem for Linux 2, right? Before this, I have seen there are some informal requests in many forums where people were asking for this capability, right? Running FreeBSD on either the Windows subsystem for Linux 1 or after that the version WSL 2. I saw some requests. Even I was posting in some social media like Twitter and LinkedIn about asking for this capability. So yeah, so when Microsoft open source the WSL Windows subsystem for Linux 2 code, this project was made possible. Moving on, so this is the high-level agenda I'm going to talk about, but at a high level, the talk is going to be on the existing capabilities that is already available in FreeBSD that makes it possible to run it inside Windows subsystem for Linux. So that's the main idea. Moving on, a quick primer on what is Windows subsystem for Linux 2, right? It is a Windows capability where users can run a native Linux distro like a Ubuntu or Red Hat natively on Windows. It provides an integrated terminal with a console window, shared file system, actual Linux kernel running inside a utility VM, which is a Windows subsystem for Linux terminology. So I've seen many developers, students try to, if at all they want to use Ubuntu on Windows or try out any other Linux distro, they use this capability inside Microsoft to run an actual native Linux distro inside Windows. It is primarily written for Linux to run on Windows. So the entire code base that is open source by Microsoft, if you notice, it is all Linux related. So why then run FreeBSD inside it? How it is possible and why? What is the motivation, right? So as I said, I have seen developers who want a Unix-like environment inside Windows. This adds capability, another channel for FreeBSD to be available to developers and students, right? In addition to virtual machines, in addition to bare metal, in addition to cloud-hosted environments, this is yet another channel where FreeBSD capability can be accessed by users. In addition to that, this project also highlights how the FreeBSD's capability, inherent capability, like the existing support for Hyper-V sockets, existing support for Hyper-V, existing P9 driver, how that makes this project possible, right? How these things make FreeBSD to run stock version inside Windows subsystem for Linux 2. So again, personal curiosity as well to make this work. So having said that, I'm going to do a live demo later as part of the talk, but I just want to quickly show how it looks like in a recorded session, just to have an idea what this is and how this works, right? So let me play a quick video and show how this works. So let's get to a command prompt and first let it show the Windows version on which we are doing this demo, just to make sure what kind of version it runs. So it will show this demo was recorded in a Windows 11 machine. So let me quickly show the version of Windows this is running on. And after this, let's see the version of the WSL2 code, the open source code that is this project was built on. So it shows that. Now let's showcase how WSL will run, how the FreeBSD will show up in Windows. So let's see. See the response time. Once you invoke, you get the prompt, FreeBSD prompt inside Windows. Let's make sure it is FreeBSD. And see the various options that shows up, the system CTL options. So it shows the hardware that is seen by the FreeBSD from within the environment it is running. So this is the loader configuration that has been set. So the BSD image and the delay, auto boot delay, those have been disabled for getting the fastest response time. And yeah, so other options. So okay, so how this is running is there are two main userland programs which are running in the background. That is what it makes it possible. I will get to that in the later sessions, but I just want to show how they are running for using the RC capability in FreeBSD. So the HV bridge and HV init was the one which has been developed as part of this project to make this possible. So they are always running in the background as a userland program without modifying anything in the stock FreeBSD operating system. So yeah, so that's a quick demo on what's coming. Let's move on to how this is being done, right? Okay, so there are 6 main areas that has been implemented as part of this project. The core is the virtualization layer, which is provided by host compute system in WSL. That's an API we'll talk about as well. Then the handshake between the FreeBSD running inside Windows subsystem for Linux 2, right? So how that handshake happens, we'll talk about that. And boot console, not the console which I showed, but the boot console when the FreeBSD is running, the guest is running inside WSL2, how does the boot console work? The actual interactive terminal which I showed, how that works, and networking and file system capabilities as well. When I say file system, it is the mounting the whole Windows file system into FreeBSD and vice versa as well. So how that can be done and what state it is now. So these are the aspects we'll go through. I will also talk about the various challenges faced as part of doing this. So yeah, let's move on. So this is a very high level architecture on how WSL operates. Okay, so when somebody uses Windows subsystem for Linux inside Windows, there are 2 main components, the WSL CLI, command line interface, and there is a background service, WSL service, which is a core, which is the actual virtualization and lifecycle orchestrator for the utility VM. So FreeBSD runs inside as a guest VM as a stock image. And as I said, there are 2 programs which have been written. One is for handling the handshake between the guest and the host. The other is the console, the program that takes care of the console itself, what we type and how the results come back. So the interactive terminal which we saw. Okay, so what is the difference between how Linux works inside WSL2 and FreeBSD, how we have implemented, right? First, the kernel. In case of Linux, a Microsoft custom kernel is being used. In case of how we have done FreeBSD, stock operating system is being loaded. And boot method, in case of Linux, first the custom kernel runs and there is a custom init called mini init which loads. And after that, the user land, like a Ubuntu distribution or a Red Hat distribution, that is mounted on top of that as a distribution. So that's how the entire system boots up when you run Linux on WSL2. Whereas in case of FreeBSD, what is being done is the entire operating system is loaded without any change as a self-contained disk image. init system, as I said, on the Linux side, there is a custom mini init which is being run. In case of FreeBSD, our standard operating system plus the userland programs which I showed and mentioned. And boot console, Microsoft expects Virtio console during the boot as primary and serial console as a backup, secondary. In FreeBSD, we are using serial console because there are some issues where FreeBSD was not loading the virtual console messages during boot. And The critical one, the interactive terminal which I showed, that works using the Hyper-V socket based, which I showed as well. So let's move on. Okay, so I talked about the 6 layers, right, which are critical as part of this implementation. The main one is the virtualization layer. As I mentioned before, how Windows subsystem for Linux implements virtualization. So there is something called HCS, Host Compute Service, which is the virtualization orchestration layer. And it's a decently documented API. And how it works is, we create a JSON object where we mention what are our capabilities that we are looking inside the inside the guest VM. So we construct that entire JSON object, pass it to the HCS API, Host Compute Service API. So using that JSON object, the virtualization layer spins the guest VM, which is called the utility VM, and take care of the rest. So the one problem I faced was the JSON schema is not well documented, or it is slightly outdated, which is publicly available. So I have to do a lot of reverse engineering by running a live Windows subsystem for Linux and figure out what the JSON is being generated inside and modify it to suit FreeBSD to run. So that's how it was made possible. So yeah, as I said, that I'll go through the JSON later. But as I said, FreeBSD is loaded as a VHDX file as an entire operating system and attached as a SCSI device inside. And that's how it is booted. That's how the interactive terminal shows up. So let's go into, this is the JSON object, which is being run as part of this project. As you can see, there are multiple sections here. One talks about what CPU, how much memory, and there is an entire section for devices to load the SCSI device or COM port or the file shares, other virtual IO devices, things like that. So once you fill in all these details, pass it to the HCS API layer, that HCS API layer spins the guest inside Windows for us to use. So this is the most critical aspect of this, both of the WSL2 and how we can run FreeBSD onto WSL. Moving on, boot console. This is one of the, so when the guest VM is booting, the WSL2 software expects a console for, debug messages, things like that. As I mentioned before, when I first booted this headless FreeBSD VM, I could see in the memory that the FreeBSD has booted, but I was not able to get a console out of it. Turns out somehow the VirtIO console doesn't work at boot time. So what I had to do is instead use the serial console. So that way, I can see the headless VM has booted in the background and log into it, do some debugging, and install the HV init and HV bridge inside that, things like that during development. So this is one of the crucial things. It took some time to figure out why the VM boots, but there is no output. So here's a difference. In Linux, VirtIO console is used, but in FreeBSD, as part of this project, we are using serial console. And yeah, as I mentioned, auto bit delay has been set to 0, and the splash image, which we see when FreeBSD first boots, that has been disabled to get maximum response time, so that you get that prompt immediately when you run WSL. So yeah, so those two settings as well are crucial. Now, moving on to another critical layer which makes this possible, which is the Hyper-V socket layer. So Microsoft has an interprocess communication socket layer, which is called HV-SOC interface. And this is the main protocol which is used for communication between the WSL2 host and the guest operating system, which could be Linux and FreeBSD, right? FreeBSD has a very excellent implementation of Hyper-V sockets already. So that is what being utilized here to make this possible. So that protocol is implemented using AV_Hyper-V socket. And so the way things work is FreeBSD has to operate as both these HVSock server and also as the client, so that the handshake can happen bidirectional between Windows and the FreeBSD. So as a client, FreeBSD runs at port 50,000, and as a server, it runs at 60,000. These are fixed. These are expectations from WSL2, so that any operating system which runs inside that can do the right handshake between the guest and the host. So this is the main socket structure which needs to be populated. I think on the WSL2 side also this is getting populated, and FreeBSD also as a server and as a client has to populate this. And most of these are by convention, so rather than configuration. So WSL2 understands a lot of these and fills in a lot of these automatically. So in FreeBSD, this structure is actually part of the kernel and not on the user land, but I did use this directly in user land, just using this in a header file. It works. Okay, so I talked about two user land programs which have been written as part of this project to make WSL2 run successfully on FreeBSD, stock FreeBSD to run successfully on WSL2. The first one is the HV init. So this program spawns a number of sockets, and also connects over a few more sockets on the WSL2 side to exchange initial boot information, status information, any issues in boot, capability advertisement, things like that are done using this socket. This is not documented at all. None of these are documented. There are a lot of handshake that happens. So these were all found out from the open source code of WSL2. Even though the source code is open, I don't think there is a documentation found for all these handshakes that is happening. So there are some reverse engineering and finding via debugging that had to be done to figure out all these handshakes that happen. So that is the Hyper-V init layer. Now the interactive terminal which we saw, right? So that is being taken care with the HV bridge program that has been written for this project, right? So what it does, it again uses the Hyper-V HV socket, AV_Hyper-V socket for communication, and it uses the master-slave pseudo terminal concepts over Hyper-V socket, right? So there is a master terminal which spawns a child shell inside FreeBSD, and that output from that and the input from the user in the interactive terminal are passed back and forth using the master. The master takes care of sending the message to the shell, getting the results back from the shell, and sending it back to the console which we saw, right? So that's how the interactive terminal which we saw, and all of these things are happening over Hyper-V socket. Okay, so little more detailed diagram here. As I said, on the WSL side, you have the command line, and in the background Windows, there is a WSL service running, which is the actual orchestrator, and below you see the FreeBSD VM, which gets spawned, and I'll show this in the live demo. And we have this FreeBSD running, and these two are the actual user space programs implemented as part of this project. And as you see, the handshake protocol happens via HV init, and the actual console taken care, which the WSL executable when the user launches and sees the console, that is taken care by the HV bridge. So this is a little more detailed diagram on what happens. Okay, so now, as I mentioned before, what are the capabilities which were already in FreeBSD, which are being used for this, right? Obviously, serial console and the native Hyper-V socket implementation, which is already available, and the proper clean kernel space and user space separation, and running background processes as part of startup, and the full VHDX model of running the entire operating system quickly, boot them up quickly, and so that we get that VM immediately and have a good response time. So as I said, so far as part of this project, it is 100% stock. There is no change, no patches, no nothing to the kernel or the FreeBSD base operating system. And so boot process is identical to bare metal. That's my personal opinion because it boots so fast. Maybe I will show. So that's what I observe. So subjective. Okay. So how somebody can? So what are the changes? How do we prepare a FreeBSD image to work inside this project's modified WSL2 source code, right? Just download the FreeBSD VHD image from our main site and convert that into VHDX. That's how the HCS expects that. And in the GitHub, I have shared the source code of the changes I have did. So just copy that into the mount this VHDX in a FreeBSD, copy those files, and it is ready. The other thing you have to do is compile the WSL2 in the GitHub, the forked WSL2 code I have published in the GitHub so that the WSL2 can call this FreeBSD. Okay, let me quickly show the live demo. So I will also show the VM getting launched in the background. Okay. So once I launch the WSL FreeBSD prompt, you can see in the task manager, there will be a process called VM-mem, which will be started. Actually, that is the one which is running the headless VM in the background. So let me start. So as you can see, we got the prompt, and there is also a process VM-mem which showed up, which is using around 500 MB. That's our FreeBSD running in the background, and we have the prompt already there. So just to make sure we are inside FreeBSD, showcasing the the version of the, so that's a host name, so that has not changed. So that's why you see the discrepancy between 14.4 and 14.3. So networking, right? So what I have noticed is Microsoft's WSL injects a synthetic network interface as part of the WSL2 inside FreeBSD. So I'm able to see that HN0 interface here. There needs to be a client-side networking that needs to happen as part of implementation. That should be a guest networking service that needs to be implemented similar to HV init and the HV bridge, which is not yet there. It's under progress. So once that is done, this synthetic driver, which is getting injected by Microsoft, will be, by the WSL2, will be used for doing internet. It's kind of sketchy now, so that's why I'm not showing the actual internet connectivity here. So that's the demo. Let's get back to our slides. So what works and what doesn't work, right? As you see, the interactive console works. You get the FreeBSD running. You get the network interface. But the guest networking service that needs to be still implemented. And file system integration. When I say file system integration, you can use the file system, either ZFS or UFS, inside the console. But to access the Windows file system inside FreeBSD, there is a protocol called 9P protocol which is being used, right? So that driver is already available in FreeBSD. That's another good thing, as I mentioned. But while doing this integration, I get an issue. I'm facing a problem. I was trying to fix it, and it's still under progress. So what's happening is WSL2 injects a 9P file system related PCI device as a hot plug into the guest, right? So when that is happening, on the FreeBSD side, all the VM bus related devices are closed, which is the HV socket layer, the serial console, everything breaks immediately. So I'm looking into it. Any help in that also is really will be appreciated. So that's on the file system, bidirectional file system integration status, which is being continuously worked upon. Moving on, full lifecycle management. So I showed the console, right? There are other aspects of the full graceful shutdown of the VM, and those things are getting implemented as well. So as I mentioned, the issue which is happening, which I'm seeing in the host integrating the Windows file system into FreeBSD, accessing that, it's having this problem, even though we have a proper implementation of the 9P protocol inside FreeBSD, which is available, but hot plugging a PCI device into the BSD is still giving error. So that part is still being worked on. So yeah, please go ahead, take a look, give a spin, let me know if you want to contribute. Yeah, it's open source. So it is available. So currently it is mentioned at WSL for FreeBSD, but I saw a lot of comments on what the name should be. Some people mentioned it is WSL, there is a Linux inside it, but is it for FreeBSD, right? It should be WSFB or WSB. Or this is forked version of WSL, so WSL should remain there. So there are a lot of questions. I'm not able to answer what the naming should be. Yeah, so this is the GitHub link. Please take a spin. And again, this project, how FreeBSD is able to run on WSL2, it's entirely because already the capabilities which is available there. So that's what made it possible. That's nothing which has been done to the base FreeBSD to make this possible, right? Yeah, any questions? Yeah.
Did you try to boot open BSD?
Not yet. It should work if it has Hyper-V socket support. Sorry, my bad. So the question is, have you tried OpenBSD as well into it? So as I mentioned, the Hyper-V socket support is one of the crucial things that is required for any operating system to run inside WSL2. So Alan had a question.
Yeah, oh,
Check 1, 2, check.
yep. So you mentioned you could also access the FreeBSD file system from Windows. How does that connect to the FreeBSD file system?
So I've seen the code of WSL2. So there is Linux side. They are implementing all the requests that is coming from Windows and responding to it. So similar thing might need to be implemented for FreeBSD side file system operations to be visible to Windows side.
So I have a couple of questions. I don't know how much time we have. I'll talk to you if I run out of time. But first question, you're using, just like bootloader, the BIOS bootloader to do all this? Is that right?
It is a stock VHDX image. So whatever comes with the VHD image in our FreeBSD site, that's used directly.
Okay, so it's the bootloader, or sorry, the BIOS loader, not the UEFI loader, I guess is the question. Do you? Yeah, so anyway, you talked about the networking side. Is that, I was a little unclear, is that working now, or is that something that we need to put some effort into?
Okay, so so the changes on WSL2 side makes sure that there is a synthetic driver, synthetic interface that shows up into FreeBSD. But on FreeBSD side, networking default gateway, things like needs to be done via implementing. So as I showed here, there is a service called guest networking service, which is implemented for Linux on WSL2 that needs to be implemented similar to the HV init and HV bridge I showed. A handshake needs to happen to make it work.
So we would use that as opposed to a DH client like one would normally use to bring up all that information. Is that right?
Yes.
Okay,
yes.
that makes sense.
What I saw from WSL2 code is it supports both NAT-based networking and bridged networking. I did try with NAT, manually configuring the interface. It did work. Internet works. But yeah, but the actual automatic service needs to be implemented yet.
Cool. I guess my last question then was around the hot plug stuff. There's a number of people inside of Microsoft that handle the VM bus and hypervisor and all that stuff in FreeBSD. Have you been in touch with them to report those bugs, or is that something we need to find people in the community to fix to allow the hot plugging of the 9P client, which is currently crashing things?
I have not yet got in touch with Microsoft. I'm trying to. One of the foundation members is trying to help me with get in touch with Microsoft, not only for this, the overall project itself, any issues, like any undocumented thing that needs to be taken care. But I'm not yet in touch with Microsoft for this.
Okay.
But that's the idea to get in touch with Microsoft.
This is very awesome, and I love it. And I've been typing in IRC, oh, we need to have this. We need to put this, into the base as an example for NanoBSD Reimagined project to show how people can just do that. So the HV init and HV. So my last question, the HV init and HV.
init. Bridge.
Both of those are in the Git repo you had up here?
It's under a folder called FreeBSD. Both the C files are available.
So I guess I would love to see those as ports. Maybe I'll start writing them. Anyway, I'll talk to you more later. I don't want to monopolize this.
Yeah.
Yeah, I'm very interested in this too. I think you watched my talk the other day about building custom images and stuff like that. I'd like to start building custom images for this, but completely different question. Have you tried running Linux simulator on it?
So nested inside.
Just really curious if you've tried that yet.
Maybe I can try. I have a live WSL here. I can. So.
Have you tried doing this inside Amazon EC2?
Sorry, which one? Right?
Have you tried doing this inside Amazon EC2? Because the M8i instances, if you're running Windows on them, you can run Windows subsystem for Linux on those. So you could probably run FreeBSD inside Windows on EC2 now.
Oh, oh, okay.
If you test it, let me know.
Okay.
And the last thing is, I noticed VMM is taking 8% CPU. Do you know where that's coming from?
So that's the process that runs the guest VM, but that process itself might have a overhead. So that's an undocumented process actually. So I can't say that the entire CPU cycle is taken by the FreeBSD VM. I can't confirm that.
That's fair.
The process itself might have overhead.
Thank you.
These are the things I need to check with Microsoft. Cool. Any more questions?
Thank you.
Okay. If not, yeah, thanks everyone for patiently listening.
do a mic check, please?
Works better. That should be better. So. Not sending, but that's probably on purpose.
Ja. Nicht bevor wir dann unendliche.
Wie gesagt, ansonsten, nachdem du Default ist, also den Konverter, ist es auch wurscht, wenn du das Kabel absteckst und so dazwischen. Von unserer Seite ist es wurscht. Es ist eher halt gesagt important, dass du halt wissen möchtest. So, der ist schon auf der
Everything good? Yeah, you tested. Yeah. You tested?
Schon.
Available just in case you need me. Yep. Sync.
Okay, welcome to low friction temporary VMs on FreeBSD. And let's start with a bit of history. Who here knows Qubes OS? Okay, I guess around half the people here. So for those who don't know, Qubes OS is an operating system based on Xen, and it's very privacy and security focused, and that means it uses a lot of VMs to kind of petition your work, your personal stuff, your SSH keys, your GPG keys, the network. And one of the features of Qubes OS is that you can have temporary VMs based on templates. And what was really nice is that you could just launch them with a single click. And while I haven't used CubeSys for very long, I really, really like this feature. So I wanted to know, can I reproduce that on FreeBSD? So what are uses for temporary VMs anyway? For example, if you want to quickly test something in a clean environment where none of your other configurations interfere with what we've done before. Or maybe you have seen on the internet some nice software which has a curl SH installer, and you want to try it out, but for security and safety purposes, you don't want to do it on your own machine, but in an isolated environment. And there are many more purposes. For example, if you just need another distro to test something on, and so forth. So what is involved when you want to create a VM? You need a few things. You need a name for it. You need a network interface. You need to select an IP address for it. You have to create a new volume based on the template volume you want to use. And you also need a serial console if you want to connect to it directly. And then once you have all that, you have to actually then set up the VM. So you have to create and start it. You have to configure the network of the VM so that it knows how to reach the internet. And this is a bit of a pet peeve of mine. I really like if SSH just works properly, and if you don't have to kind of just type yes blindly, but that you actually have the key properly configured in your known hosts file, and you don't have to just trust whatever the server says, and also that you have your keys on the VM so that you can just connect to it and you don't need a password or anything. So we need to extract the SSH host keys that the VM uses, and we also have to put our own host keys, our own public keys on the VM. And so that the VM can also reach the network, we then have to also configure the firewall rules. This includes that we want to filter the traffic so that it cannot reach the other VMs or our home network devices, that we have the proper netting, so net translation, and maybe we also want to forward ports from the host to the VM so that we can maybe reach it from the outside if we have some service we want to access. And you see there are a lot of steps, and all of these things cause friction. And so if you have to manually intervene, if you have to select the names or IP addresses, if you have to configure all the networking things on the VM, if you have to manage the firewall rules, or and then once you're done, you also have to clean up all the resources that you have created. Now you have to clean up the network interface, the serial consoles, the SSH keys, because you no longer need them in the known hosts file. And personally, I also like to keep things simple. So we don't want to use a daemon, we just want to have a single program. We want to have a minimal state, so as little config file as possible, and as little configuration as possible. When we have no daemon, we also need to ensure that if we run multiple temporary VMs in parallel, that they don't kind of start to interfere with each other, so they kind of still have to coordinate in some way to select different IP addresses and different names for the devices. And also, of course, that the firewall's rules don't conflict with each other. So our goal is to have temporary VMs. We want to have them in a low-friction manner. We want to have them on FreeBSD, because that's what I'm running. And we want all to be simple. And, of course, we also want to have fun by doing it. So what components are we going to use for this? Well, first, we're going to use FreeBSD and Beehive. We're going to use ZFS for the volumes. We are going to use TAP for the network devices. We use PF as a firewall. We use Cloud Init to configure the VMs. And we use memory disks and GUnion to configure the template volumes. And maybe you have not heard of all of these, so I'm going to go quickly through them so that we're all on the same level. And we're going to use DM for the serial console. So let's quickly talk about the relevant aspects of these components so that we are all on the same level. So Beehive is the hypervisor for FreeBSD, and the main user space command to manage that is just Beehive. We are using ZFS for the volume management. So ZFS is a copy on write file system. and it also supports parse volumes. And volumes, like file systems, can also have custom properties. These are just then key value pairs you can associate with a volume. TAP are the virtual Ethernet devices. And you can just create them, and then you can, from user space, open them and read and write to them. And these, what you write and what you read them, becomes packets in the host networking stack. And you can create them with the ifconfig command. And you see they have a number n. And if you don't give an n, the kernel will automatically select a suitable n for you that isn't used yet. We use PF as a firewall. It's one of the 3 firewalls in FreeBSD. It supports the standard filtering rules. It also supports nutting. And it also supports redirection so that you can forward ports from the outside to another IP address. And PF allows you to structure the rules into anchors. So this is like a tree, and then you can just extend nodes in the tree with new rules. And this way you have a structured way to configure your firewall rules. The MD module allows you to create in-memory or file-based block devices. For example, you can just have a file and say, please mount this as a block device. And then it's just a block device like any other. You can create partitions, you can create file systems on it. G-Union combines block devices together. So you have 2 block devices. One is on top, one is on the bottom. And when these can get turned into one block device. And then when you write to that combined block device, only the upper block device gets modified, the lower device stays unmodified. Cloud init is used to automatically configure VMs. And it has options for everything, including that you can configure network interfaces, that you can configure authorized keys. You can also, if you want to have Ansible roles and create static files, execute commands, whatever you want. Cloud init images exist for both FreeBSD and also Linux distributions. So it's quite easy to get them. How they work is you create YAML files which specify what you want to do, how you want to configure the VM. Then you have to put them all together into a special volume. And that volume is then attached to the VM. And then when the cloud image boots, it looks if it sees the special cloud init volume. And then it looks at the configuration files and executes them. Some of these configurations only happens once per instance. And the question is, how does Cloud Init know if it's the first time running on an instance or if it's maybe a reboot? And the answer is that there's also an instance ID in the configuration. And as soon as this instance ID changes, it means it's a new instance, so it reruns all the configuration. And this is quite useful because this allows you to just change a template to have a new template. And then when you boot that with a new instance ID, it's considered a new VM. So you can progressively modify your templates in different ways to your liking. NMDM is the null modem driver. It has a pair of connected TTYs. They are called like dev NMDM NA or NB. And the N can be chosen. And you can use CU if you want to connect to them and use them. So how do we then put this all together to create our temporary VMs on FreeBSD? First, we have to name things somehow. And to create unique names, we first start with a unique VM ID. And this VM ID then we use then to create the VM name and also to derive the IP address. And now the question is, how do we get a unique ID for our VM if you don't have a daemon? So we need some way to ensure that if I run two instances in parallel, that they don't accidentally decide to choose the same ID, because otherwise there would be a conflict. And how we do that is we create a new tab device, and if we just create a tab device without giving a number, the kernel will select a unique number for us. So the very first thing we do is we simply create a new tab device, don't give it a number, and then, courtesy of the kernel, we get a unique ID we can use. The VM disk is then just a G-union of a memory disk on top of the template volume. So this means that the VM just modifies the in-memory data, the template volume stays unmodified. Multiple VMs can use the same template volume at the same time, they just have different in-memory disks mounted on top of them. And what's also a nice side effect is the kernel uses its superpowers to lock the lower volume against modification. So there are no cases where you can accidentally modify the lower volume, and this would then maybe cause trouble for the VMs. The kernel has a special way to lock this lower device that other processes cannot modify it. How do we handle the networking? So for the network configuration, we use the CG NAT range, which is the carrier-grade NAT range, which is 100.64/10. It's the same IP range which OpenBSD's VMD uses by default, so I thought this is a good choice and used it as well. We then separate off that a /31 pair of two IP addresses, one for the VM, one for the host. And we use the VM ID when deriving this IP address so that we can get different IP addresses in that range. An advantage of the CG NAT range is it's not very often used. So if you're in local networks, you have like the standard private networks and not that one, so there are no conflicts with that. We don't use DHCP to kind of keep the moving parts low and also to keep it simple. On each boot, we use Cloud Init to statically reconfigure the IP addresses the VM uses, and that works really well in practice. And we also have an option to use the 10/8 range for the IP addresses if we want to. This is then to avoid conflicts, because what happened once is I was using some VPN software in a VM, and that VPN software also used the carrier-grade NAT range. And it was very strict, and then decided as soon as it started, it would not allow any traffic from the CG NAT range except through its own VPN interface. And suddenly I was no longer able to connect to the VM because the external interface also used the same range. So this is why there's this option that you can also use 10/8 so that you don't have this conflict. For the PF configurations, we're going to use a very restrictive rule set. So we don't want the VM to just reach any host. It should not reach the local private, the other VMs, and also not the private ranges. We're going to NAT the outgoing connections. And we're also going to forward ports using redirect rules. And we collect all the rules in an anchor which is named after the VM. So this means that each VM has a different anchor which it uses. And by the tree system, PF then just goes through all the VM anchors. And now when we redirect ports, there is a question. How can we have safe forwarding? What do I mean by that? If you, for example, imagine you have now two VMs running and both want to forward port 80 to itself, then which one would be taken? It should be kind of an error that only one can forward port 80. Also, for example, maybe you have, it's on a remote machine and the VM wants to forward port 22. Now, this would be a problem because you still want to reach the host machine. You don't then just want all traffic to go into your VM. And what happens is the redirect rules, they grab the packets really, really early. So if you, by accident, redirect port 22 to the VM, you can no longer reach the host because the redirect rules just grab the packets as soon as they're coming in and pushing them out to the VM. So how can we kind of prevent these issues? And again, the answer is we use the kernel to ensure exclusivity. So we just bind on the host to the protocol, so TCP or UDP, and the port. And that way, if there is already SSH listening, there would be an error because not two services can bind to the same port usually. And also, if another VM is already, for example, forwarding port 80, the second VM trying it would then also get an error because port 80 is already forwarded by the other VM. But having this listener is not a problem because the packets that would be destined to this address are diverted to the VM beforehand. I already mentioned it before, I really like a good SSH setup, so let's talk a little bit about this. The first question is, if we start a VM, where do we get the public keys? And I'm not sure if you know it, but within a process session, there's an associated login name. And I found it out once when I was in a root shell, and suddenly some command was asking me to authenticate because I was Martin and not root. And I was like, but I'm in a root shell, how do you know that I originally was Martin and just used Sue to get to root shell? So this feature then preserves the login name, and doers and Sue usually keep that unmodified. So even if you're in a root session, you can find out which user was there originally. And we then use that to get the user's home directory and the public SSH keys. And then we just hand them off to Cloud Init, and Cloud Init makes sure that they end up on the VM in the right spot. And at the moment, this is completely over-engineered because it's just me anyway, so I could have also just hard-coded the keys. But I mean, it's so nice to do it that way, I think. Now, we also need to configure our local SSH that we can just connect to the VM and already know what host keys to expect, etc. What Cloud Init does, it prints the SSH host keys to this serial console, and from there we then just grab them and put them in known hosts. And we create a separate config and known host files for each VM, so again that we don't have conflicts, and also that it is easy to clean up when we're done, because we can just delete the config file and no host files. And this is also important because otherwise, if you then use, again, a VM which has the same name, suddenly the host keys don't match and SSH is unhappy, so it's better to just clean it up. And this then leads us that we can just do something like SSH TMP0, and we just get connected, everything working, host keys correctly configured, authorized keys correctly configured. And we don't have any manual checking of host keys. One more thing we need is we need to get the SSH username of the user to use inside the VM, which usually is, depends on the cloud image, but maybe you have also done some custom configuration and want to use some other user. And to create the SSH config file, we need to know which user do you want to be inside the VM. And for that, we actually have to kind of store a little bit of configuration. And the question is, where do we store it in a sensible spot? And for that, we use the ZFS custom properties. So to the template volume, we just add a new property, which is called VM username. And then we say this is Ubuntu or Fedora or FreeBSD or whatever else we want to use. And that way, it also stays with the volume. So once you no longer need the volume and delete it, there's also no other configuration to clean up. And this is then what like a sample SSH config looks like. So we have our host name, we have our user, and there's also specified which custom known host file to use where the host keys are, which we before grabbed from the serial console of the VM. So now how did I actually then implement that? And this is the tool TVM, and I know the name will not win any prizes for creativity. It's written in Rust. It's around 1,500 lines of code. And I also try to keep down the dependencies. So there are 5 direct dependencies, which then results in around 40 indirect dependencies. And because all these VMs are only temporary, what's really important is that we have good resource management, that we afterwards can clean up everything which we no longer need. And the question is, what are resources anyways? So these are like the tab interface which we created. It's the memory disk and the GUnit device. It's the firewall rules we have created for the VM. It's the cloud init volume, the SSH config, the known hosts file, and also the beehive process, which we then have to properly terminate. And so how does this cleanup happen? And because we use Rust, we can just use the borrow checker to do the cleanup for us. And who here has heard of the borrow checker? So maybe short introduction how the borrow checker works. It's probably, I would say, the most well-known feature of Rust. It's also usually the thing you have the first problem with if you're using it for the first time. And what it does, very simply speaking, is just it restricts aliasing, so you can't have different names pointing to the same object. And because the aliasing is so restricted, it can then also decide at the end of the scope whether all the names for an object are gone, and if all the names for an object are no longer available, it can then just clean up the object. So it's not like garbage collection, which then hunts sometimes in the future. It hunts deterministically at the end of the scope when it's no longer reachable. And this is called the value being topped or destroyed or cleaned up. And here's an example how that then looks like in the code. So if you want, of course, Rust knows nothing, for example, about memory disks. So we just create a new struct which just consists of a string. This string is the name of our memory device. And then we say here, okay, if this object memory MD is no longer available, you just run this command to destroy the device. There are also a few convenience features in TVM. For example, there is a --RO flag, and this just lets you mount some block device read-only into the VM. So if you want to debug the file system of a Raspberry Pi, you can just plug it into a FreeBSD box, launch a temporary VM with that volume attached inside the VM, and you also don't have to worry about it accidentally getting modified. There's a small console which you can use to change the firewall rules, and it also automatically loads the kernel modules and enables IP forwarding, which I usually forget. Now, how do we interact with FreeBSD from Rust? Well, for things like KQ or signals, we just use the libc and nixcrate and call these directly. For resources, like the network interfaces or the memory disks, we just use the user space commands, and we just exec them. And when available, we use libxo to provide JSON output, which is then easier to parse. So when we want then to configure a new template, we have to get the cloud init image somewhere, and then we just copy that into a ZFS volume. We then can launch also a VM directly from the template volume. This is the same process as with a temporary VM, except that we don't have this memory disks on top of it. We just directly modify the lower device. And then once that's running, you can just configure it manually, or you can also just write some Ansible roles which do the job for you. There is unfortunately still a little bit of one-time setup before you the first time use the tool, but you have to add an anchor point for the PF roles to your PF config. You have to add an include directive so that you can include the custom VM configuration for SSH. And you also have to install a package to get the UFI boot ROM. And then you would have time for a short demo. Can everybody read that, or do we need to increase the font size a bit?
Yeah, we can bump it up.
Is that better? So here we can just then create a new temporary VM. It tells us what ID it has chosen, what name it has chosen, also what IP address it uses. And now in the background it creates the cloud init volume, attaches everything, and saves the host keys, and then it tells me that it's ready. And then I can either connect with the serial console, or I can just connect via SSH. And there we go. And now we can also, for example, see here the GUnion device. So on the lower side, we have the template volume, which is just a ZFS volume. And then on top, we have our memory disk. And here we can also see it has created tab device 0. That's also by its VMID 0. And here in our SSH directory, we have the configuration and the host keys. And then once we no longer need it, we can just shut it down. Now we see no more SSH configuration, no more tab devices, and also no more GUnion devices, so it's all cleaned up again. What are my plans for the future? Well, I really want to get some kind of secret injection to work, that I can automatically also configure SSH keys inside the VM, which the VM then can use, for example, to check out Git repositories or access some services. Currently, the tool does not yet support restarting temporary VMs, which is usually not a problem, but if you, for example, want to do some kernel work and you install a new kernel, you need to reboot the VM to get into the new kernel, and if then the VM just exits and deletes all the temporary files, you have a bit of a problem. And so I want to support it, that you can maybe also do some kernel experiments with that and just reboot the VM. I also want to consider to combine that with jail, so that we have even a better security and separation. I integrate it with ZFS snapshots, so that maybe if you modify a template volume, that it creates a snapshot before, so that if you're not happy with the modifications, that you can just roll it back. And I also want to support temporary VMs for OpenBSD, because OpenBSD has no cloud init images as far as I know. And that would also be cool if you could make it work with OpenBSD. There's some related work. For example, there are dev containers which are based on the same idea, that you want to quickly spin up some temporary environment to hack on things. There's KubeOS, which I mentioned before. And there's also the VM Beehive shell scripts, which are more concerned with persistent VMs and have no features for temporary VMs. So, in conclusion, temporary VMs are super useful, and I find new uses for them each day. And working with FreeBSD is a lot of fun. And with that, are there any questions?
Quick question. Is it possible to have the temporary VM auto-delete to return to disk space? You spun up 3 or 4 of these at a time. wanted to get that space back, is it possible to auto-delete?
What do you mean with auto-delete? You can just stop them and then they are cleaned up. But there's no mechanism externally that somehow just says, oh, let's kill machine number 1. The question was if there's a mechanism to automatically delete the VMs if you're running low on space, but you just have to notice that yourself and then turn off the VM.
How many VMs have you spun up just to test the stress level?
How many VMs I have spun up to test the stress level? I've never really stress tested this, but I guess I had around 4 or 5 VMs running concurrently.
You mentioned you were using the borrow checker to automatically release resources. So in the kernel, like for instance in Beehive recently added a mode where as soon as a VM exits, it will automatically destroy itself. Like in general, it seems nice if the kernel itself can recognize, oh, this resource is going to get destroyed on last close. Would that make your life easier if we were kind of more aggressive about implementing features like that?
So the question is that the FreeBSD kernel has recently gained some capabilities to delete resources that are associated with the VM, and if that's not easier than using the borrow checker. Yes, certainly it is. Right now, I didn't know about that, and also like things like, for example, the temporary SSH configuration. I'm not sure how you would associate that with a kernel process. It would be cool if you could do that, right? And I would just say, take care of these things, and then once the process exits, just clean them all up. But even if I could move some parts in it, it would be, I think, a valuable addition.
So, I mean, do you ever have issues with, the runtime, the borrow checker is trying to clean up resources, and for some reason it returns error, like you try to delete a memory disk, and maybe somebody's running fine about the file system, so it's still open, and then you get an error. Do you ever have like problems like that? Or?
If the question is if I ever had problems when the borrow checker failed cleaning up resources. Usually not. Usually it works quite well, but I'm also ignoring the error so that the cleanup can proceed in other steps. So if there would be some problem, it probably would just keep then the resources around, and then they would get cleaned up at the next boot.
You mentioned that you use this a lot. What are your top 3 things that you tend to use in these lightweight VMs?
The question is how I use them personally. For example, yesterday I wanted to look up something in a man page, and I simply spun up a VM, installed a package so for easily accessing the man page directly. Also, if I want to try out new software, I just spin up a temporary VM. If I want to quickly kind of see, okay, what are the steps to get this working properly, I first do it in a temporary VM, and then probably create a new template from that, so that I can just try out, and everything that didn't work will then just not be in the template.
So I was expecting to hear like you run a web browser like Firefox, always in this, to keep it contained.
I'm not doing that yet, but that's a nice idea.
Your naming conventions, when you had the TMP0, I'm assuming TMP1, 2, 3,
Yeah.
it goes like that. Now, assuming that I kill one of the machines in the middle, like TMP4, if I spin up another one, will it reoccupy the TMP4, or will it continue to the last +1? How is that done?
The question is how the naming works for the temporary VMs, because it's temporary TMP0, 1, 2, 3, 4, 5. And the question is what happens if I kill TMP2 or stop TMP2? Will the next temporary VM be TMP6 or TMP1? And the answer is, I looked it actually up because I wanted to know, we could use the IDs from the kernel, so I looked up into the kernel, how does the kernel get the IDs? Does it just have some atomic integer increments? But it doesn't, it actually kind of tries to find the lowest available ID and has a mechanism for that. So it will be TMP1 again.
So assuming I started some process in TMP0, let's say external connection to TMP0 that was trying to do something, then I kill this one but spin up another one. Now that connection will again try to come back to the same TMP, whatever number that was, correct? Technically speaking.
Yes, but the forwarding rules will also have disappeared, so it will probably then just get problems with the hole.
With the new one, the forwarding has again reinitiated.
If you redo the forwarding rules, but all the rules are cleaned up when it VM exits. So if there's a new VM. The question is about what happens if a VM gets deleted and a new one is created in place, what happens to the incoming connections? And if they're coming from the host, which knows about all the SSH config, it will just connect to the new VM. But if it's some external processes which work via the redirection rules are also dropped. So the new VM will not have them, and then they will just go to the host or host file.
Okay. Yeah, makes sense. Thank you.
Yes?
You mentioned that you use the unique ID you get from the TAC interface to select your IP address. It wasn't immediately obvious how you came up with .3 for your IP. Can you elaborate on how you select your IP address based on a unique ID of 0?
So the question is how I use the unique ID to select my IP address. And I think at the moment I just use it like for the third component, the VM ID, because we have more than enough addresses anyways. I'm never going to run that many VMs. And even if I were, we could just change the scheme that it uses the bits more efficiently. Yes?
Is this tool available for us to play around with if we wanted to?
The question is if the tool is available. No, it isn't, because I'm not quite happy with it yet. There's still some to-dos in the code I want to clean up first. I really hoped I would manage to do this for now, but every time I go back to it, I'm like, oh, this I could do nicer, and oh, here is this to do. We should fix that before releasing it. Okay, when there are no more questions, maybe one last thing. You may have noticed that I have 2 speaker tags here, so I'll do a little advertisement. Have you ever written to dev null and wondered how does that work behind the scenes that the contents actually disappear? Well, there's a talk about this tomorrow, so join me tomorrow in 11:10 and find out at 2:30.
improved even more. And today, this is from one of my systems, and I took this yesterday. It's basically one of my 3 talking to the outside systems. As you can see, the offset is under 1 millisecond. Is there anything left you could want? I mean, seriously, if you need a clock closer than 1 millisecond, maybe a generic Unix and an NTP-driven clock are not what you need. Now, with the accuracy being solved, or that problem being solved, there's still these cases we really want to deal with. Like, what if we get lied to? NTP is unencrypted, unauthenticated. It's just plain UDP. It's not even TCP. And UDP is pretty easy to spoof. So a spoofed reply, or even a malicious server, could give us a wrong idea on what the time is. And this could be the beginning of an attack, in theory at least. Talking about spoofing, if the attacker cannot see our queries, which would be the most common case, you would need to do blind spoofing, which means he needs to know both IP addresses and both ports. The IP address of the system he's attacking, he'll know. The IP address of the server the system is talking to is probably not all that hard to guess. Like, every country has official servers, and you're very likely to use them. So those should be easy enough to guess in many cases. The server port is 123 by definition, so that is known as well. Leaves one potentially unknown, the local port of the client. For the reference implementation, that always is 123 as well. In OpenNTPD, you just use an ephemeral port. On OpenBSD, that's random, and that already is hard to guess. So that's a big improvement. It's still not all that much. So the protocol implies the request that the client sends contains a transmit timestamp, the time when the client sent the query. It's 32 bits for the milliseconds and 32 bits for the fractional part. So we have 64 bits. The server is required to copy that verbatim to the reply he sends us back. And we don't actually need the transmit timestamp. Well, we need it later to do the math, but we don't need to send it. We can keep that locally. We have a local state. So we have 64 bits to play with. And we'll just use a 64-bit random value to put in there that is not a timestamp at all. It's a cookie. When we get the reply, we'll verify that is exactly the cookie that we had sent out. So now a possible attacker does not only have to guess IPs and ports correctly, he also would have to guess a 64-bit random value. And this is very unlikely to succeed. So this mostly solves the blind spoofing case already. It does not solve the case where the attacker can see our traffic, and it does not solve problems with malicious servers. If the attacker sees our stuff, he knows all this, so he doesn't have to guess anymore. You may have bigger problems than NTP in that case, but still we like to get this under control as much as we can do. If you use multiple servers to sync to, and you should, there's a very good chance an attacker can only see queries to one or few, or just one of the servers you talk to is malicious. So you have to find the outlier. And this is actually solved in a very easy way. From all the offsets we learned from all the servers, we won't take the average, we'll take the median. And the outlier is not affecting us anymore. So to fully solve this, the way we attack this in pretty much every other protocol is apply crypto. There actually was a definition for that, like an NTP protocol authentication scheme, horribly complicated, X509, ASN1, everything. And unfortunately, there's no way around that this makes the configuration very complex. You have to do all the key management and everything. And that absolutely goes against the desire to run it on every host with little to no configuration. Right? This was one of the main points. We want every host to have a synchronized clock. It would be possible to come up with a better scheme. However, there's no installed base, and we would be the only ones implementing that. And especially when you're the newcomer entering the scene, we won't find anybody else implementing that. So this didn't seem a viable route. HTTP to the rescue. HTTP 1.1, it was not there on 1.0, has a date header. And if we use HTTPS, everything is authenticated and encrypted. So there's no spoofing problem. However, if our clock is really, really, really far off, validation of the server certificate is a problem. Like if we're a year behind or a year ahead, the validity check will fail. So we cannot just use the regular certificate validation that is in libTLS, libSSL, libcrypto. We have to do it ourselves and either not look at the valid from and valid to fields at all, or only do it when we are already pretty certain that our clock is close enough. Now, the obvious problem with that is the resolution of that is 1 second, which obviously is not good enough to synchronize our clock. But it is good enough as a constraint. We'll still learn the offset through NTP down to a few milliseconds. But if those unauthenticated and unencrypted NTP packets communication tell us that we are like a year further than the HTTPS learned offset is, it obviously is wrong. And if it's not a year, it's only 10 minutes. Still good enough. So what we do is we match the NTP learned offsets against a small window around the constraints that we learned via HTTPS. And again, if we have multiple constraints, we will use the median and not the average. Again, if there's one outlier, it doesn't affect us. The OpenBSD default config, I'm running way too fast through this here. Anyway, the default config that OpenBSD ships with is this. We'll sync to servers from pool.ntp.org. The servers means if that resolves to multiple IP addresses, and the way DNS works, this is 8, we'll use all of them. We will sync to time.cloudflare.com. This is only a server, not servers, so it will pick the first IP address and talk to that. If it doesn't get a reply, it'll go on to the second, and so on and so on. But it will only use one at a time. Sensor store means if the kernel presents us a time sensor, like a piece of hardware, or these days very common, you're running in a VM, we'll have a time sensor that is provided by the hypervisor. If there's any, we'll use it. And then there's constraints. We will ask quad 9. We will ask quad 9 in V6, which isn't really quad 9, but anyway. And we will ask Google. And same thing as with server and servers. From these two, we'll take 1. From Google, we'll take up to 8. Additional bits that you would have to do manually if you wanted to, if you want to redistribute the time in your network or to other hosts, NTPD needs to listen on some IP address, be a server. On OpenBSD, you can make it listen in different routing tables or routing domains. You can specify the source IP address of the queries you send out. You basically never need this, but there are a couple of corner cases. And you can mark servers as trusted. What does that mean? You typically do this inside your own network. When NTPD starts up, it has to figure out whether the clock is reasonably close or way off. We don't want to continue booting until it did, because you don't want to jump the clock ever. And foremost, you don't want to jump backwards. So the boot process on OpenBSD does not continue until NTPD figured this out. When you say trusted, it'll take a single NTP reply from that server to figure out whether it's off or not, and if required, hard set the clock. If you don't say trusted, it won't do that. So, really way too fast here. Have the goals been achieved that I put out there? Security, there hasn't been a single issue in 20 plus years. So I'll say yes. I think it is lean. The total is about 6,000 lines of code, of which a pretty big share actually is the constraint code. So I call that lean. Does it cover more than 90% of the use cases? I think so. We've actually never had a request for features that we did not implement. So apparently it does the job. Did we get synchronized clocks everywhere? Well, the only thing we really have control over is OpenBSD, of course. On OpenBSD, NTPD is enabled by default with the config I've shown. So if you don't do anything, that's what it will do, sync to pool.ntp.org and Cloudflare. So for OpenBSD, solved. There are OpenNTPD packages available for all the BSDs as far as I'm aware. And it also is available on many, many, many Linux distros. Not sure it's all, because there's so many of them, but pretty much every I know has a package. Is it easy? I think it is. It's enabled by default. You don't need to do anything. And could I prove that my little framework was good for more use cases than just OpenBGBD? Well, it's being used by more than 25 daemons in OpenBSD today. The internal messaging code is in libutil. I say that's a yes. So I'm quite happy with the outcome. And there's another goal achieved. I delivered a talk. A bit too quick, but whatever. Questions?
Where does the slide with all the math on it about how NTP works?
Where's the slide bar?
With all the math on it about how NTP works, with weird acronyms like PLL and
That was in my talk 20 years ago. The math is surprisingly easy. It's basically 4 timestamps. Yes, please.
Where are the features?
Oh, I can't hear you. I'm not 20 anymore.
What are the features that the reference implementation has but OpenNTP does not implement?
Since I have not really looked at the reference implementation for more than 20 years.
Repeat the question for the stream.
What does the reference implementation have that on features that OpenNTPD doesn't? I have not looked at the reference implementation in more than 20 years. So I know that they have their complex X509 ASN1 authentication scheme. They do have some broadcast or multicast for within a local network without much configuration. They do implement older protocol revisions that just don't matter anymore. There probably is more, but I just don't know. Because, you know, I like my baby.
This 64-bit cookie that you're doing, because that isn't a timestamp, is there a possibility that makes it incompatible with upstream NTP servers? They would reject your...
Okay, the question is whether that 64-bit cookie we insert instead of the transmit timestamp could lead to compatibility issues. Never say never, but the specification clearly says the server has to copy that timestamp, those 64 bits, verbatim into the reply. It is not allowed to do anything with that. So anything that would break would not be NTP. And we have...
Just not reply.
Pardon, if
it could just not reply.
Of course it could just not reply, but we have never ever seen a case. Like everything seems, or obviously does what the specification demands and just copies that value into the reply. So has not been a problem in practice. The 64-bit cookie trick actually was not new for NTPD. We already did this in the rdate -n thing. So that even predated OpenNTPD. And in that case, because rdate would only send a single query, you would have noticed immediately. So that just hasn't been a problem, and I can't see it being a problem ever.
Of course, if you don't know what time it is yet, of course you might send a wrong timestamp. But if the NTP server is supposed to tell you what time it is.
It's a very good point. If you don't know what your time is, the timestamp you sent, how would the other side validate that? Like it could verify it's in the right century or something. But nobody does, obviously. I think you had a question?
My question was covered by the cookie question.
Okay. Albert.
Have you ever looked into further getting rid of the root pid by having more fine-grained permission on the time adjustment part? Or are you just fine with saying that's so stripped down that I don't care that it runs as root?
Okay, the question basically goes down to, do we need the root process to do edge time, edge rec, and set time of day versus allowing more fine-grained control over who can call these? In general, like I'm a big fan of keep it simple and stupid. And history really shows whenever you're trying to go super fine-grained on permissions, they quickly become unmanageable. So this has never been a discussion at all, and it is reasonably easy. Like when the framework's there for multiple processes and the intercommunications, it is reasonably easy to have that root process doing the work. And that is a very clear boundary, easy to follow, easy to audit, easy to verify. So I think that is the way to go. Kirk.
Also, I mean, you wouldn't port to other systems if you didn't have the root permission, because they...
That's very true. Another scheme would not work on other operating systems. Now, admittedly, edge rec is not standardized at all, so that is not super portable either. I did make a small modification to the edge time syscall. It has two parameters. One is the adjustment, and the other is a pointer to structure where the kernel tells you how much of an offset it still has to adjust for. Originally, you couldn't call edge time without giving it a new adjustment. And I made a small modification. You could pass a null pointer in there and just get the remaining adjustment that the kernel still needs to work on back. So in theory, this was not portable. As far as I know, pretty much everybody picked this up, because it's a simple modification and it just makes sense. The portable version of OpenNTPD has differences exactly there, interfacing with the kernel timekeeping. I think Linux has some edge time access familiar. I'm not quite sure. I don't do the portable. I reserve the luxury of only dealing with OpenBSD. What I know, where I can change the kernel. In many regards, I think this is showing a pretty general approach that we have on OpenBSD. Like we aren't writing a little daemon in isolation. We are looking at the whole picture. If you want to write an NTPD that's perfect everywhere, there's basically no way around that userland timekeeping, because you don't know what the operating system gives you. But I think it makes much more sense to make the general timekeeping better for everybody and everything, instead of the very specific NTP problem space. So the whole picture approach. And yes, portability, that's the downside of it. But it has worked out because Linux has other mechanisms that could be adjusted for. The other BSDs picked up our changes. And, well, what else is out there that matters? I'm not aware of anything. Yes, please.
How much does the root process do? Is it basically just like an RPC call, or does it do any math on its side before it makes the change?
Okay, the question is how much does the root process do? It's extremely limited. It's basically, actually, where's that slide? One of the early ones, the Lego one. Here we go. So the root process, there are 3 internal message types it even knows about. And they perfectly map to those 3 syscalls. So you could call it a relay.
So it's basically just an RPC call.
It verifies the requests it gets as much as it can do, and then it does the syscalls, and that's it. Yeah. So that's super simple. And again, that is easy to audit, because we're talking like 2 hands full of code. And if we screw up in the other processes, we're at least not giving root away, which is the entire point of further separation. Yes, please.
What all time sources do you support? Is it just other upstream servers, or do you support other time sources?
What other time sources do we support? One, there's the other servers, NTP, speaking NTP to the other. The other little bit that I had in there was sensor star. We don't solve this in OpenNTPD. We let the kernel do it. The kernel has time sources, like for hardware. You could plug a GPS receiver in. GPS gives you very accurate time. In OpenBSD, this will show up as a time sensor. I already mentioned the VM case, which back then didn't exist, but I didn't have to adjust NTPD at all, because the time sensor that OpenBSD as a guest under a hypervisor gives you from the hypervisor shows up the very same way that the GPS sensors did. Okay. And there could be basically anything else, as long as there is a driver that presents us a time sensor, we'll use it. Yes, please.
The message passing framework that you wrote for the BGPD and then also used in this, I think that's in the OpenBSD kernel now. Has that been ported anywhere else? Because it seems like an interesting approach.
Has the message passing framework been ported and used elsewhere? By itself, I don't think there is nothing in there that is operating system specific. So basically anything that's reasonably close to POSIX should work. Okay. It has been, as I showed, it has been used in a bunch of daemons on OpenBSD, and a bunch of those daemons do have portable versions. So it does work on other OSs. I am aware of, say, maybe a handful of like third-party software using it. There may be much more. I mean, this is the usual problem we have with open source software. We never know who's using it and who's doing what with it, right? So I don't know. I do know that there are cases. I cannot say how many.
Okay, thank you.
Do you want to pick a fight who's first? No. You're sitting further up front.
So if you're not involved in the portability side of it, and you're just involved in the core bit, do you consider the project done after 20 years?
So the question is whether I consider the project done. You're a FreeBSD person?
NetBSD.
NetBSD. Do you ever consider NetBSD done?
No. But
The answer is no.
The 90+% of features, you're not going to bother with the next 10%.
That's Canadian beer.
I'll take a beer. Oh, and I did something here. I think we're out of time anyway, right? Yes. Yes. So thank you for having me. Thank you for being such a great audience. Thank you for being such a great BSD family.
book of PF and ranting quite a bit of about sanity or lack of in IT. It's really my involvement in running systems based on open source software that made me appreciate good engineering, good quality in software. And for the last 4 or 5 years, I've been doing talks about, well, this topic really, the quality in software engineering. One thing, my slides are full of links that may be useful if you're into this subject. So I put you can just scan this QR code or type in that URL, so you'll have it locally if you want it. I've also just published an article that has the main points, which follows really closely here. So, and yes, well, why the EU Cyber Resiliency Act and what it has done for you or what it can do for you. It may sound strange coming from someone who lives in a country that's actually not part of the EU, but we're so closely associated that it doesn't matter. And anyway, but let's first dispel one misunderstanding. The EU CRA is not the end of the world or the end of free software. I will argue in some detail that it's actually a good thing for free software. And we will come back to that, and I think there will be some room for discussion. And of course, if there are any, I will take questions during the talk as well if something needs clarification. So, well, let's start with, I tend to scare my audience with, yes, it's later than you think. It's actually 12th of December next year. It's too late. Because if you don't have your shit in order then, on the December 11th, the European Cyber Resiliency Act enters fully into force, which means that all products with digital elements marketed to be available in the European Union must come with full overview and insight into description and origin of all components, description and origin of all dependencies. If your product requires a CE mark, the certification for legal use in the European Union, well, if you don't cough up these things, you're off the market. You're facing retractions of a product. Like, take it off the market. Reporting on all vulnerabilities and incidents involved in your product with digital elements will be required starting September 11th this year. There is, if you follow some of the other links in this presentation, you will find there is actually a coordination centers set up for the European Union to point you to the correct member state reporting authority. So it's it's not quite as scary as it sounds. But anyway, this is where we are. If you're a big enough corporation that needs to start doing something, well, I think you're late. One recent development is that actually from here on, it's the European Union that takes leadership in establishing standards for our security. The CRA is not the first relevant legislation here. The European Union has enacted a number of acts during recent years. We have the General Data Protection Regulation, the GDPR. You have the regulation for the Digital Operational Resilience of the Financial Sector, also known as DORA. And you have the Directive on Network and Information Systems, NIS2. All this legislation has in common that it's intended to make conditions of use and operation for products and services in the European Union safe for citizens and businesses. And actually, it has quite some consequences for things like personal health and safety and civil rights. Up until quite recently, the coordination of these kinds of legislation was fairly good on both sides of the Atlantic, but the equivalent of the CRA that was enacted in the United States was an executive order signed by the previous president, and it took the Trump administration exactly 1 year and 9 days to partially retract that one. So the specifications made by some parts of the federal government, they're still there, they're still available, but applying them is now optional for federal agencies. So the EU is now the standard setter. It's not, it's not what we used to, but here we are. Now, the CRA sets out a number of things like, well, I can tell you this, legalese is a specific discipline, and European Union legalese is yet a variant of that. So it's tough going. The act itself is quite large, but for our purposes, there are really three categories of people or organizations that matter to us. You have the manufacturers. These are businesses that put products on the market to be available in the EU and markets them as part of commercial activity. Keep that in mind, part of commercial activity. You have open source stewards. That are organizations that coordinate open source projects. They are typical of foundations such as the FreeBSD Foundation. They may own infrastructure. They will have some sort of cooperative coordinating function. Again, we will come back to the requirements. And then you have open source maintainers. These are individuals or may even be businesses. But the reason why this is not the end of open source, one thing is that it says in the recital 18 that this regulation does not apply to natural or legal persons who contribute with source code to products with digital elements qualifying as free and open source software that are not under this responsibility. Which means if you write code, put it on the internet, somebody else uses it, well, that code, well, even if we're responsible for writing that code, if somebody else uses it and something goes wrong, that is not your problem. So basically, you're home free on that point. Well, if you're an open source developer or open source steward, under the CRA, individual open source developers actually have no formal obligations. But as part of, following from the obligations that will fall on manufacturers, you might be encouraged to adopt certain best practices, which might be, well, which I will argue will be part of good engineering anyway. Open source stewards, again, are usually foundations, not for profit, but they could be regular companies, only but the open source stewards are people or organizations who have a coordinating role in the open source projects, and the various articles of the CRA specify the duties which are not that onerous, but what perhaps the most burdening one is that if such an organization runs infrastructure, the same requirements for incident and fault reporting and handling apply to those as to that specific infrastructure as it would to any other operator. So a little more responsibility on the organizations than the individual developer, but again, not that horrible. On the other hand, if you are a manufacturer, you are responsible for the product you market. You need to ensure that it's actually fit for a purpose. It is aligned with all applicable requirements and certifications within the European Union. It comes with the necessary documentation and technical information, including a bill of materials for all components and dependencies, software bill of materials, which is a key component here, detailing the product's digital components and the dependencies between them. So after you have put the product on the market, you are responsible for maintaining it, also reporting what they notify the reporting authority, usually the telecommunications authority of the member state or some other government body that has the reporting authority. You will be responsible for maintenance and basically bug fixing. Should you not live up to those obligations? Well, you could be. There is a scale of possible reactions, including product recalls, and for repeat offenders, fines of a size of whatever is larger of 15 million euros or 2.5% of your global turnover. So if you're a large enough corporation, this will be real money. So, but why is this happening now? Well, software, most of us here are deeply involved with software, but we also must remind ourselves that software is not really understood by the general public, really. Historically, it was basically considered unimportant, or if it was considered important, it was so easy to just make the innards of it a trade secret, which means that you really, there's no way you can inspect something that's and do proper security verification on things you can't see. So that led to a so-called IT security industry that was really would do some things like collect malware signatures. You might even do some network scanning, but for the most part, the security industry tended to ignore what I think is the central part, the developer and developer practices, which has been just glossed over by mainly the part of the industry that considers their software source code to be trade secrets. So, in contrast, what we do with open source software is, for one thing, it's available. You can verify that it actually works, does what it says. You can study the source code, and most projects will encourage other third parties to report back if they find something off, if there are bugs. Now, if your project is interesting enough, well, people will start reading it, and they will find things that break, and your product will be better. And I would say in at least large parts of the open source world, there is a strong focus on code being of high quality and correct for the purpose. And in some parts of the environment, there have even been some. Well, the OpenBSD project is known for recreating software so any even unknown future bugs would be harder to exploit. That would be. That has been the topic of several conference talks earlier, and I can point you to some good references if you like afterwards. And well, anyway, much more point here is that for open source, well, we've been growing up in public all the time, and having your source available, it actually inspires you to follow best practices and do what you think is best. Now, for a bit of history. Again, historically, software is just a bit of typing, you know. And again, in historical perspectives, we really only have had software for since the 1950s, roughly. Again, poorly understood by the public. And again, several of us in this room are old enough to have heard that yes, that is just a bit of typing, something like the the typists do, the little ladies who don't understand anything. And again, not important, a necessary evil, and this changed over time. And but in the pre-internet age, software was either unimportant or important enough to be proprietary. You can get at the important parts. But then, of course, something happened. The internet happened. Changed our world. Two very important things happened. First, which is obvious to anybody in this room, is that our infrastructure became dependent on open source software, mainly BSD software. The internet would not have worked without the BSD code. And that infrastructure, again, was built by engineers who understood the value of rough consensus and working code. The other thing that happened was that, well, we didn't get 10,000 chips typing, but we had millions and millions of people running stuff that was really not intended for network connection, like your Windows computers and so forth. And bad things started happening pretty fast. The public wasn't prepared for this. The internet became scary and so forth. And of course, the initial reactions to these included things like Linus Torvalds, "With a given enough eyes, all bugs are shallow," or the proprietary answer is that open source software can never be secure. Well, I would say that there is some truth in both, but really they're not true. Either of them not true. And what led to the thinking that gave us the CRA and its international analogs were you put something on the internet that is proprietary, such as the SolarWinds network management software. In 2020, it was discovered that, well, somebody, probably a state actor, had managed to insert into software to the automatically distributed installation or an update packages for SolarWinds Orion, some code that was not part of the SolarWinds code base, which facilitated entry into classified networks that run the software. There is a fairly good write-up on how the thing happened by that link. So keeping your software as a trade secret does not protect you. And SolarWinds was the thing that actually nailed that home for even the non-techie public. The other one that given enough eyes, all bugs are shallow. Well, then Log4j's Log4Shell happened. Log4j is a logging package for Java, And it turned out at least one version of that, when probed correctly, would give you a shell on the machine running the software. The problem, of course, in both of these incidents, well, they had this in common, that it turned out a lot of organizations didn't really know where the affected software ran. How many copies do we have? Which systems depend on this? So, yeah, well, it was kind of scary, and it led to memes like this one, where you have all modern infrastructure that actually hangs on somebody, maybe a lone maintainer somewhere, and the upshot was, well, as I say on the slide, you may choose to trust your supply chain, but you also need to verify. And how do you do the verification? And this is equally valid for open source and proprietary software. You need that verification step. Now, just for kicks, after a few years, modified versions of that meme started appearing, which I think is this one's probably closer to the truth. And actually, just last week when I was preparing those slides, another version came out, which. So, well, anyway, so this is our chaotic. This is what our life has turned into. Now, how do we deal with this? When we are aware that our dependencies and our development model may look like something like the XKCD thing here, with there are so many moving parts interlocking. And we need to start by going back to the first principles. Dear developer, do you know what your code does? Do you know everything it does? Well, the answer there is, well, probably you know what your code does because you wrote it yourself. But your code depends on, or pulls in other dependencies. And do you know what these things do? Well, that's where the work starts, really. And some of this is actually mandated by the CRA. So summing up so far, we write software which depends on other software, which interacts with other software, and which interacts with other components, such as hardware and even humans. And some of our software runs important stuff like the internet, or something that keeps control of your money, or healthcare. And none of this exists in actual isolation, or we could say no project is an island. So what we do is important, and so what do we do about that? Well, take a step out and let's learn from the people who build important things. Like, consider the aircraft carrier HMS Queen Elizabeth. The exploded view here is meant to indicate that, well, this one actually consists of several thousand subcomponents, and each of them, in other engineering disciplines, there is a thing called a bill of materials, mainly a thing that you will be required to hand over, so somebody who is not you will be able to maintain the thing. And, well, there's an anecdote. Well, one thing is that it's actually the bill of materials thing required by the U.S. Department of Defense that led to was one early driver for development of SGML, the standard general markup language, which is the precursor of HTML and XML. But anyway, what a bill of materials looks like, well, and again, we have something like, well, this is a random bill of materials I found for a water pump that might be part of the boat. And yeah, and going back to the aircraft carrier, there is an anecdote that one of the recently commissioned aircraft carriers for the US military came with a bomb of more than 1 million items, ranging from some number of quarter-inch bolts to one nuclear reactor. And you would assume that the nuclear reactor came with a bomb of itself, with probably limited circulation. Now, Some of this will sound familiar for free software developers, because in the free software world, we had package systems. Like, it must have been a few minutes after FreeBSD was actually first running when somebody started building the port system, because you need something to have fun with the computers. An operating system is fine, but you need something else, and that something else existed elsewhere, and you needed to patch that, and you came up with the part of, well, everything has dependencies, and it starts sounding familiar. So we have package systems that take care of runtime and build time dependencies. At least, depend on your build systems, and this means that the information, we are actually used to handling the kind of information that would go into a software bill of materials. And of course, in addition, we have stuff like that traces any known vulnerabilities in running software. There's a lot of that out. That's small part of the so-called security industry that I actually sympathize with. So, back to the present. We have these still existing, but no longer actually required executive order from the Clinton administration and the Cyber Resilience Act that where really boils down to in order to secure something, in order to keep something secure and maintain your product, you need to know what it is. You need to know the components. You need to know the dependencies. And again, for the software part, the information we need actually is in our code. What we need to do is make it a part of our development process that we always generate that information so we can hand it over to our customers. Unfortunately, well, we're engineers. We have tools. Work on something like the modern SBOM software bill of materials specification has been underway at least for a decade. And during recent years, the OWASP Foundation came up with their SBOM specification in parallel with the Linux Foundation, which have their own SPDX Foundation. Two standards are not necessarily better than one. And it shows up in, actually, they mostly map, but there are places where they don't. Then again, most of the tools that are available, and the tools I will be mentioning here are all open source. There's several of them are available to are able to do some kind of conversion between the formats, but there will be corner cases, and things might bite. So, so it's useful to be aware of that. So, in practical terms, for a software project, well, given that we have tools like CDXGen, that's mentioned in this slide, and SIFT, these are the two more popular. What you need to do is, for your software project, you have a new build artifact, which could be as simple as, well, when you, as an aside, when you're thrown into a new project, you might actually learn a lot by just running those two commands on your new project. CD to the project directory, run an SBOM generator that will give you a JSON file that outlines what your dependencies are. That takes you maybe seconds, and you know a lot more about the code you're about to start maintaining. That's how I try to motivate my colleagues. Do this, and you know more about the code. And yes, this is so. So the end of it is that you can move move quite a bit on the way to being CRA compliant by just adding a line to your make file. Which, well, if you find the appropriate tool, C is actually sort of, well, it's a work in progress for it to make make proper SBOMs for C code, but it's not impossible. So, from our perspective, the SBOMs are really one of the important tools for providing, well, for quality assurance and for transparency into your product, and it is becoming required for certification of products that need certifications. For products with digital elements that need certification, well, the SBOM needs to exist. The crybabies on the commercial side made sure that you do not need to publish the SBOM, but you need to make it available to regulators and to people who are involved in the certification. And the takeaway from this is, for open source, SBOMs are tools for transparencies, so we have a clear win there. And it's so easy well, for most products, it's really easy to just add that build target, and you will have a data set to push into whatever system your customer uses to verify your dependencies. And the SBOM management dependency tracker system is likely OWASP's dependency tracker, which is free software. It's a big blob of Java code, but unfortunately it requires Postgres as its database background. So it's in most environments it's very easy to get running. If you run a sane Unix, yeah, well, you're probably already there. It probably is already a package. Now, state of play for the BSD projects. Well, state of CRA readiness in open source projects, of course, varies. I can confidently say that quite a bit, even though there's been a lot of activity in SBOM and dependency handling in open source world in general, and the Linux Foundation has been deeply involved in some of the work, the actual level of awareness is not that great. It's improving. For the BSD part, the Free BSD Foundation is actually funding CRA readiness work to the point where, so there is some work ongoing. There is no public statements from the NetBSD or OpenBSD communities, but we have seen manufacturers like Genoa in Germany have at least communicated to me that since their customers tend to be parts of the German government that's already heavily regulated, yes, we do these things. Just ask us in a few months. Now, the problem, of course, for the BSDs in general is that, as we say in the OpenBSD part of the world, bin is full. Especially if you're looking at introducing tools that are written in a language that is not C. You really do not want one more language in the base system. And the problem, of course, is that the more capable SBOM tools, well, one, they are not written in C. Sift, which is quite popular, is almost all Go. ZXGen, I was surprised to find, was 95.7% JavaScript. And yeah, well, it's back to the same thing, that things that are not written in C are not really that welcome in a Unix-based system. Now, the FreeBSD Foundation is funding a project for getting ready for the Cyber Resilience Act. They published a blog post last year. And it turns out that they have a contractor, Pierre Branchery, who's here somewhere, Hi, Pierre. And please correct me if I say something wrong here, Pierre, but the plan is to make a modified version of package config, which originates in NetBSD, which is able to emit SBOMs. So FreeBSD 16 will have that tooling in base, which will make it easier for manufacturers who base their product on FreeBSD to be CRA compliant. And so basically, you have FreeBSD, it comes with an SBOM. Your extra parts, they need an SBOM too, and you can merge them, and you're really far along the road to being CRA compliant. You also need a organizational infrastructure to do bug reporting and fixing and so forth. But just being able to offer the SBOM data is a key component here. So summing up, yes, the future is bright if we engineer up. The European cybersecurity has been rising awareness as part of a product with digital elements. And the way I read the CRA, at least, is that a product, anything that is able to make a network connection is under the CRA in some way. So, and of course, your software does not run in its isolation. It runs in hardware, and once it's packaged with hardware, that becomes a product with digital elements. And there you go.
Yeah, so I guess I would comment that the ETSI, ETSI, the European Telecommunications Standards Institute, or whatever it is developing standards for a whole range of products. Scanning through it, I don't see anything that are explicitly like software as a service, but there's whole categories. So if you make a firewall product, you're going to have to comply with this regulation. Yes. A password manager, a web browser, pretty much anything with a network.
Basically,
and there's a whole series of them that are almost done.
Well, the thing is, please, anything that costs more than maybe $500 that does not have a network connection in this day and age, go to your car, for example. That calls home all the time, and or your whatever you use to play your music, or for that matter, the laptop. It's again, the United States has decided to consider this not really important anyway. But if you're a manufacturer and you are intending to sell into the European Union, this is for you.
Yeah. So I just encourage people who are making products to look at what ETSI's putting out. Things have been coming out for comment, so you should review what you're going to have to do. And there's been a lot of work going on. I'm a member of ETSI for some other work working on standardizing the language around memory safety, which turns out we went in and we were like, oh, that's really easy. We'll just spell it out. And we're like, no. It turns out it's super complicated to describe. But all these things are coming along, and newer standards coming in the future are going to, require memory safety and things like that.
Yes. Yeah, that's definitely relevant. But again, for the CRA in itself, is really you need to have a proper declaration of your what is in your product and all the dependencies. So yes.
This is only tangentially related, but you mentioned that it seems like the EU is starting to treat software engineering as an engineering discipline.
Yeah,
do you also foresee...
As evidence here?
Yeah. Do you also foresee the European Union starting to impose other engineering-related obligations, like professional ethics certifications on software engineering, or do you think that's a bridge too far currently?
I would not be surprised, but it's not part of the CRA as far as I know. But, one thing I forgot to mention is that every time as part of this presentation, I mentioned the Canadian engineers' iron ring. That anecdote really hits people. So
thank you.
Yes. I think it was somebody over there. Yeah. Oh. Any further questions? If not, I won't keep you from your coffee break. So, thank you.
A, B, C, I hear myself now. Okay, stream is live. Okay, I will get started then. Hopefully without feedback. Okay. Okay, I will be talking about FreeBSD 15. This was, of course, what I spent the second half of last year doing, pretty much. I submitted this talk with the title of how FreeBSD 15 landed, because I thought that was what the program committee would like. That's not the real title of the talk. The real title of the talk is FreeBSD 15.0, What Went Wrong. So a lot of you I know, we've been at this conference for 2 decades or so together. But for those of you who don't know me, I've been a FreeBSD developer since January 2004. I spent almost 7 years as a security officer. I ported FreeBSD to run in Amazon EC2, and I've been maintaining it ever since I got it running. Because I was involved with building those release images, Glenn asked me to join the release engineering team in August 2020 as a deputy lead, or as I sometimes refer to the role, hot spare release engineer. I took over in November 2023. I am an Amazon Web Services hero. They gave me this fancy title because of the whole EC2 thing. I am not employed by it, and I do not speak for Amazon, but they do actually sponsor some of the work I do on FreeBSD EC2 these days. So I mentioned I took over as a release engineer in November 2023. EuroBSD 24 in September of 24. I'd been in my role for long enough, I sort of decided what I wanted to do as release engineer. Influenced perhaps a little bit by American politics, I decided that my motto for my time as release engineer was I want to make FreeBSD releases boring again. In order to do this, I shortened the release cycle. We typically had 4 betas and then 4 release candidates before we did a release. I said this sounds a little bit strange. If something is a release candidate, then just in terms of what those words mean, a release candidate means it is a candidate to be a release. So if we are building RC1 and we already know that that is not what will be the final release, we know there are still serious outstanding bugs that we will wait to fix, then it is not actually a release candidate. So I aimed for 3 betas and 1 release candidate, which compressed the whole calendar, and it actually worked. I told people this is a timeline, and they got their patches in a lot faster. I announced a quarterly release schedule. So we have releases happening in March, June, September, and December. The minor releases take 3 months to do, essentially, and so they all fit within 1 quarter. And then every second year, every odd year, the second half of the year is doing a new major release. .0 releases take a lot more time. There's no way we can do one of those within 3 months, so that gets 6 months. And then we support the major branches for 4 years, so we have 2 concurrent major branches at a time. Releases are now frequent. Before I did this, we were doing a release like every 5 or 6 months, so it's almost twice as frequent as they were before. They are very predictable. I don't actually put the schedule for a particular release onto the website until a few months before that release cycle starts, but you can look at the schedule for past releases and basically fill in the calendar yourself, which is useful for customers who want to plan out ahead. When will we need to upgrade all these servers? When will we need to take things down for upgrades? If companies that are providing drivers, it's good for them to know when do they need to get the latest version of the driver in order to hit a particular release. And also, hopefully, it is easy for the release engineer. Doing it this way means I can tell somebody, you're too late for this release, but don't worry, there's another one coming in 3 months. And so FreeBSD developers are a lot more willing to hold off on their not quite ready code, whereas in the past we often had delays in releases because developers would say, but I really need to get this into this release because customers need it. People really need this feature, and if I don't get it into this release, they're going to have to wait another year. Well, they don't have to wait so long anymore if you miss a release. So let's start looking at releases. With only a few very rare exceptions, mainly if I'm talking to the security team about issues that haven't been announced yet, I CC the release engineering team on all the emails I send about releases. I make a big point in all the emails I send to developers and in the guidelines for submitting change requests, do not email me personally. You should never send an email to me personally. You should send an email to the release engineering team. And there's a few reasons for this. First, it's important for the release engineering team to see things so they can catch any mistakes I make, because I do make mistakes sometimes. And second, I'm not going to be release engineer forever. I'm not planning on leaving anytime soon, but somebody will be replacing me, and if they have many years of seeing every single email I sent about release engineering, they will have a much better idea of sort of how to do things when they take over. So this made it very easy for me to put together this slide. I just went into my sent email and searched for emails sent to re@, and well, 13.3, I sent 101 emails, 14.1, 132 emails. You know, these are all around 100 or slightly more than 100 emails for each release. 350 emails I sent about 15.0 release. But good news, it went back to normal after 15.0. I also looked at how many commits happened between beta 1, which is when you create the release engineering branch, and the final release. So these are the late bug fixes and also the pro forma commits, bumping the version number, things like that. 47, 77, 50. You can see 13.5 was a very easy release. Only 36 commits went into there because it was the last release from the 13 stable branch, and nobody was doing very much on that branch at that point. But yeah, these are generally around 50-ish. 344 jumps out a little bit. There were a lot of patches going into the tree, even after we hit beta 1. But it went back to normal. 15.1 was unusually large for a major release, so for a minor release, but well, you might expect a .1 is going to be more difficult than a .2, .3, or .4. Now, I'm the release engineering lead. I'm the release engineer for particular releases. My role is a project manager. I keep track of what's going on, and I poke people. I say, hey, you told me you were going to fix this bug. Where's the patch? Has it landed yet? Do you think you're going to be able to get it done in time for the release, or should we just mark that down as this is not getting fixed for the release? At the point that I am jumping in and debugging things myself, it means something went wrong, because the project manager is not the line engineer. The project manager is making sure that somebody else does the work. So on a good release, the only commits I'm doing are bumping the version number, tagging the tree. Well, usually I'm not doing that many commits. 5, 10, 14.2 is unusually difficult. There were a bunch of issues with the OCI containers where I was going in and fixing things. But yeah, usually at least half of the commits, probably more than half of the commits I'm doing are just the pro forma version number bumping and so on. 15.0, I was doing a few more commits than usual. But it went back to normal after that. That's good. Of course, all those I was comparing 15.0 against a bunch of minor releases. So that maybe is not a fair comparison. So let's compare 15.0 to previous major releases. Look at all the commits that happened between when we branched off of main and when the release happened. 270, 154, 405, 361, and 905. This was a major release, and it was a major release. So I think I made my point. Stuff went wrong in that release cycle. It did not go nearly as smoothly as we would have all liked. Why did things go wrong? Well, here's one of the reasons, package base. In January 2016, this email came around saying, let's package up the base system using the packaging tool we are using for third-party code. Fairly soon after that, email came from the release engineering team saying, we are planning on packaging the base system with package for 11.0 release. And it didn't happen. And then we were going to do it in 12.0 release, and then 13.0 release. And those of you who've been in the project for a while know it became a meme. People ask, when is package-based landing? And the answer is, it is coming in the next major release. It doesn't matter which the next major release is, but it will be in the next major release. There was widespread agreement in FreeBSD that as a project, we wanted to have package-base. I say widespread, it was not universal. I did not personally want package-base. I don't like the fact that we now have a SQL database in the hot path for applying security fixes. That is just fragility I do not want in that system. However, there was widespread support from the community. A lot of people loved the features. The core team also said, we would like you to make package-based land. And I said, well, I am the release engineer. My job is to ship the release that people want. So at BSDCan 2024, I put my foot down. I said, it's time that we stop talking about package-based and actually make it happen. Now, yeah, herding cats is a difficult thing to do. We have 300 or so cats building the release. But if you want to herd a cat, there's a very easy way to do it. You get a laser pointer, you shine a dot on the ground, and the cat will chase it. So this was me shining a laser pointer at the ground, and the FreeBSD developer community chased the dot on the ground. I said we were doing package-based, and suddenly we were doing package-based. There was another issue that came up that made things difficult. Zero trust builds. August 24, the Sovereign Tech Fund announced they were investing 686,400 euros into FreeBSD. My understanding is this peculiar number was just sort of what a bunch of numbers added up to. I thought they would have gone with a round number, but apparently this is just how things work. One of the 5 projects that they agreed to fund was called Zero Trust Builds. And the main point of that was that it would be possible to build FreeBSD releases without needing root privileges. Also some issues with reproducibility, although those had mostly been sorted out before we got to that point. This was very important work. It is work that I had personally wanted for many years. I'm not the only person in the project that wanted it. A lot of operating systems out there have had this sort of thing for a long time. We were a bit behind the game on that. So it was absolutely something we should do, and I'm very grateful that the Sovereign Tech Fund came forward and agreed to fund it. January 2025, Sovereign Tech Fund renamed themselves Sovereign Tech Agency, and the work on this started. Throughout all the way through 2025, I had monthly calls with the team that was working on it. Alice was coordinating it out of London, which, since I'm in Vancouver, meant I was getting up very early, the second Tuesday of every month. But I was on those calls, Alice was on those calls, Mark Johnson was on those calls, a few other people, to make sure that we all made sure we knew what was going on and everything could land in time both for the product to be finished because it was being funded for the year, and also for it to all land in FreeBSD 15. Now, as is typical for a major new release, a major new feature, there were a number of issues that came up with package-based that need to be fixed. As is typical for a major new feature, there were many issues that came up that need to be fixed with zero trust builds. What I missed, and this is really my fault here, I missed the fact that these were both dealing with the same code. The build process, in particular the release building process. And so this is a classic example of 1 + 1 is 3. The interaction of these two features led to a lot of issues. And although each of these features got very well tested on their own before coming into the base system, as soon as they both landed at the same time, and it was pretty simultaneous, suddenly a lot of issues came up that nobody had foreseen. So here's one example. Etsy mastered password. where anybody using FreeBSD, anybody using any of the BSDs is familiar with this. The default one is installed as part of a FreeBSD runtime package. Of course, if you're upgrading your system, then it merges any changes in that with your existing master password, which probably includes some users of your own. I suppose somebody might just do everything as root, but most of us have our own users we add to the system. And a post-install script from that package runs password make db and also services make db in order to create things like etc password db and secure password db, which is the files that libc and so on uses to look up users, because they are those utilities are not looking at the master password file directly. In 15.0 beta 1, we shipped VM images, which had the master password file, but did not have any of those databases, because those tools that create all those databases did not know about the metalog file. And so when we were doing our zero trust builds, it took everything in the metalog file and stuffed it all into a file system. Metalog file said, we need to have etc master password. It did not say we need to have etc password db. So the long-term fix for that is tools like this that we use in the FreeBSD-based system to create databases need to be aware of, if we are building a VM image, you need to write things into the metalog file. If you're creating a file, you need to tell us that you're creating a file, because otherwise that file is going away when we create a disk image out of it. Now, I did not have time to start rewriting those tools. Those tools come from, I don't know, Kirk, what was it, 1980 something? Kirk's nodding. So yeah, I was not in a mood to go spelunking through 40 years of Unix history. The quick hack was I just added a few lines into the image building script saying, here's some extra files that we need to stuff in, even though nothing that has been installed had actually told us that we needed those files. Another fun one, the makefs tool that actually creates a file system creates file system objects as it reads the entries from the metalog file. Well, you can't actually create a file until you create the directory that it lives inside. Okay, so the makefs tool helpfully creates the file. If it hasn't been mentioned yet, it will just go ahead and create the directory that it needs to put the file into. But, well, that's not quite what we wanted, because it creates it automatically with 000 permissions. Because 0 is just the default. You don't want to accidentally make a directory more open than it should be. OpenSSH, as it turns out, doesn't work very well if etc has 000 permissions. It says things like cannot read configuration file. So the long-term fix is we need to have the makefs tool read everything and do some canonicalization and sort entries and generally be aware of the entire operating system before it starts creating the file system image. Again, I was not going to be rewriting makefs at that point in the release cycle. So the quick hack was I have a script, I have a shell script which is running, and I have a file which has file things in the wrong order. I pipe it through sort. Sort metalog, redirect to metalog.temp, rename metalog.temp to metalog. Here's a fun one. 15.0 beta 2. Now I use EC2 for smoke testing, weekly builds. Amazon very generously gives me an account which basically I can do anything I want and not pay for. So it is great for just spinning things up and seeing what breaks without worrying about my budget. I don't have a budget. So every weekly snapshot build and all of the betas, I have a script I run that spins up FreeBSD on a bunch of different instance types, AMD64, ARM64, different sizes, different flavors of FreeBSD. I have base images, I have cloud init images. And I found that beta 2 SSH was failing with this permission denied public key error. Well, it seems strange. My EC2 code has scripts that get the public key from EC2 and create the user to stuff it into. So I thought, oh, did I break these scripts? Well, fortunately, EC2 now has a serial console. In the early days of EC2, it didn't, but there's a serial console, so I was able to log in, and the user had been created. My public key was in the authorized keys file. Anybody here want to guess what the problem was? Front row.
Ownership of .ssh?
Hmm?
Ownership of the .ssh?
No, the .ssh directory was owned correctly. It was created by the script with the right permissions on it.
Ownership of the home directory and its permissions.
The home directory was created with the right permissions. Any more guesses? No, that was correct. Yeah, at the back here, on the side.
Ownership or permissions on slash.
That is correct, yes. So did you hear about this when it happened? No, okay. Well, you got there a lot faster than I did, because it took me about 2 hours to figure this out. None of the package-based packages owned slash, because they were, their packages designed for installing something into a file system, not for creating the file system. So when MakeFS was creating the file system, it said, I have not been told about this thing called slash. I will just create it with 000 permissions. OpenSSH was running because it starts as root. It accepted connections. It printed all the usual things to the logs. It's only when you try to log in that, as part of the privilege separation, it becomes the target user and then tries to read the authorized keys file. As soon as it becomes a target user, it cannot read anything, because even slash it can't get to. So if there's anybody here who works on OpenSSH, I have a request. If you cannot read the authorized keys file, please return an error which is not public key is incorrect. Because you have the wrong public key is definitely not the same error mode as your permissions are wrong and we cannot read the file. November 15th, we were at beta 5 at this point. I mentioned I want to have 3 betas. That did not happen. We were at beta 5, and he messaged me saying, these VM images don't seem to be package-based. This surprised me, because by this point, we'd been using package-based to build VM images for like a bit more than a month. So I told him, like, look, I can see the code that's building. I'm like, we are using package to extract files into this directory. And he said, well, I just launched this in my emulator, and I'm running package, and it says I have no packages installed apart from package tool. Well, it turned out that when we were building, the code which builds the VM images only added the local SQLite file into Metalog if we were installing other packages. If the only thing that was there was package base, we didn't actually put that database into the file system, into the Metalog file, which meant that it was not being packaged into the file system, which meant that package, when it was first run on the system, said, oh, I don't have a package database. Clearly, there are no packages installed. Now, the fix was, I have a shell script. It has a number of places where it adds lines to the Metalog file, so I just add another line, add this thing to Metalog file. That was a quick hack. The long-term fix is probably that when package decides it should create a file, including its own database, it should know how to emit that into Metalog. One of the biggest issues during the release cycle, though, wasn't a particular bug, but the issue of debugging agility. All the beta and RC builds, I aim to start them at midnight UTC on Friday mornings. It usually takes about 24 hours for the builds to happen before I can send out the announcement. It takes like 10 hours for the releases to actually build, and then takes a few hours to get out to all the download mirrors, and we need to build the package-based bits separately, the package-based repository to be published. We need to build the FreeBSD update bits for people to update to the release. I think the record is like 20 hours to get the announcement out. Sometimes it goes a little bit later. I am a human. I do human things. If I need to pick up my daughter from preschool, then sending out the announcement can wait for an hour. But around 00 UTC on Saturdays is when the announcement goes out. Now, the best time for patches to land is within 48 hours of that, because ideally, we want them in the tree by the beginning of Monday, because that's when the 16 snapshot builds run. And that's also 3 days before the stable snapshot builds run, which means if you get bits into the tree on Sunday, then you are merging them into the stable branches on Wednesday with a MFC 3 days, which is the standard in FreeBSD. Then they're in the standard, in the stable snapshot builds that day, and the next day, ideally after I have seen that they did not break the build in stable, I can then cherry pick them before we do the next beta. 48 hours is not a lot of time, especially over a weekend, but at any point in the week, 48 hours is not a lot of time to find a bug, figure out who is responsible for the bug, get them to patch the bug, get the patch reviewed, and get it into head. Anytime the problem comes up, you round up the usual suspects. If there's a problem with package base, you ask the people who work on package base. If there's a problem with zero trust builds, you ask the people who work on zero trust builds. If the build broke in 15, or if there was really anything broken in FreeBSD 15.0 release or betas, that was not clearly localized to a particular part of the tree, I said, okay, this might be package base, or it might be zero trust builds, or it might be both of them combined. So the whole approach of round up the usual suspects, it's a lot easier if there's only one usual suspect. If you see a bug which is in an area of the tree that only one person has been working in, you know who you need to talk to. Having these two colliding features, both dealing with the release building code, made it a lot more difficult to identify who I needed to talk to about a problem and how to get it fixed. So, lesson I learned from this, don't land two major projects in the same area at the same time. It sounds obvious. I did not realize how much these issues were going to collide. In hindsight, when the FreeBSD Foundation said, we've got money to do this zero trust builds thing, we would like to get into FreeBSD 15, I should have told them, sorry, the release building code is being churned for package base, and you can wait for 15.1. Package base had to go in 15.0 because that's a major reworking of things. That's not something we can do on a stable branch. The process by which we build images is something we can change on a stable branch. So zero trust builds could have waited for 15.1. Package base had to go in 15.0, and if I had told them to wait, they would probably have been very unhappy with me because they had money from Sovereign Tech Agency for work to happen in 2025. But I think the project would have been better off even if the foundation was very unhappy with me. Now, as a project, we don't really have any process for making decisions like this beyond the release engineer can veto things, which, the release engineer does not want to veto things. I was explaining about this to some people a couple of weeks ago, and they said, so now that you saw what happened, have you put in place a process to make sure this doesn't happen again? And my answer to them is, well, this is a volunteer organization. Heavyweight processes generally don't work well in volunteer organizations because people get annoyed with process and they just go home and do something else that's more fun. So for FreeBSD, my answer is, I'm not going to put in place a process that says if you're committing something that touches more than 10 files or a change is more than 1,000 lines of code, then it needs to be approved by the release engineer, and you need to produce a checklist of which subsystems you deal with, and that's not going to work in FreeBSD. What I can do is educate, and that is why I submitted this talk. That's why I'm here today. Somebody watching this talk, maybe somebody in this room, maybe somebody who's watching it online right now, or maybe somebody who's watching it on YouTube later, will be the next FreeBSD release engineering lead. So I don't know who you are, but whoever you are out there, I hope you learned this lesson. I hope you remember it, because There will be some time when you are release engineering lead and two projects want to land at the same time, and landing projects, landing releases, it's like landing a plane. If you know what you're doing, you're not under a lot of pressure, you're careful, you can land a plane on the runway. Trying to land two planes on the same runway at the same time does not go well. Now, FreeBSD 15.0 release was scheduled for December 2nd. I announced it 8 minutes and 57 seconds late. Speaking of planes landing on runways, I had my laptop out about 5 minutes before midnight, ready to send out the announcement. And then I was told, so you have to put your laptop away. We are about to start descending into Las Vegas International Airport. You are not allowed to have your laptop out while we are landing the plane. So I put the laptop away. I got it out after I got into the terminal. Missed that narrow window while the plane was landing. So from that perspective, it was a successful release. We landed a major feature that had been blocked for 10 years on schedule. But it involved far more heroics than it should have involved. I was working essentially full-time on this. I was not being paid for that. Amazon actually came to me in October and said, we would like to sponsor you to do more FreeBSD work. I said to them, yeah, money is great, but I have a release to land. I cannot take your money right now. And I know other people were spending very long hours getting things fixed for the release. That should not have been necessary. We cannot run a project on heroics. We need to run a project on being better organized. There are also more loose ends than I wanted. By the time that we shipped 15.0, I had already started the in-flight issues for FreeBSD 16.0 wiki page, and it had 16 items on it. Things that I really hope will get fixed in the next year because I want them out of the way before we start the 16.0 release cycle. Things like getting packaged into the base system. A lot of them we talked about yesterday. Yes, it was yesterday at the FreeBSD Developer Summit. But yeah, I would not have been able to do this by myself. Of course, there were a lot of people that helped both building FreeBSD generally and also specifically with the release issues. In particular, I want to mention Ivy, Mark, and Alex, because Ivy was my go-to person for package-based issues. Mark was my go-to person for anything related to the Zero Trust Builds project. And Alex just did a phenomenal amount of work on documentation because you would not be able to use package-based if we did not have documentation telling you how to use it. And I'm horrible at documentation. I am very, very lucky that Alex came along and said, I can write docs. I will make this happen. So yes, thank you to everybody, and especially those three. Of course, most of you know, FreeBSD 15.1 shipped on the 16th. FreeBSD 15.1 is boring. This is what I want. Okay, questions? We have a microphone here, which I think may be turned on. And somebody can run it around. Albert's coming down. That is, if anybody has any questions. I don't see any hands up yet. Was it that boring? I guess there's no questions. Oh, wait, we have one over here.
How's this? Is it working?
Yes. Yep, that's working.
So I've got 2 or 3 systems that are still running on the old update process, and my laptop here is on package base. I really appreciate the rolling out of how to do updates with package base, because it's not like the one-liner of what do I need to do to install the update is
is still a process that I'm learning. The last time I checked, the package basify script was not being shipped. Is that going to be, is that coming in 16 or is that going to come before 16?
Package basify definitely needs to be in widespread use before 16 because 16 will not have FreeBSD update.
Okay.
So you will need to use package basify sometime during the 15 lifecycle before you upgrade to 16.
Well, I mean, I will, but it's not shipping with the system.
It's not in the base system. I can't recall if it's in the port. Somebody was talking about having it in port tree. I'm not sure if that has happened yet.
The last time I heard about it, it pointed to a random Git repository.
Yeah. Well, going from 15.0 to 15.1, going from 15.0 to 15.1, my primary focus was make sure that we can actually do package-based upgrades. My primary focus was make sure that we can actually do package-based upgrades because this is the first time people have upgraded from a supported package-based system to another supported package-based system. But before 15.2, I would definitely like to make sure that package basify is a better tested and more easily accessible tool for people to use, yes.
So you're on this kind of quarterly schedule. Are you getting enough of a break between them that's a realistic thing to keep going? Because I mean, you can't work insanely nonstop forever.
Yeah. So when I put together the schedule, I deliberately put in a bit of a break there. I said, ideally we ship the release in the first week or so of the third month, and then the rest of the third month is sort of time in case things slip. As you know, with 15.1, it slipped by 2 weeks. Things came up. Warner will be talking about a particular bootloader issue tomorrow at the Lightning Talks, which is one of the things I was very happy got fixed. But the first month of the quarter is also not that busy. That's when I send out the email saying, hey, reminder, there's a release coming, and then we're going into code slush. Instead of being stable, it's now pre-release for 2 weeks. The first beta is the first Friday of the second month of the quarter. So I built that time, yes, to give the release engineering team a break, and also to give us a time slot that we can do release engineering stuff that's sort of more long-term. If we want to redesign how we do releases from a mechanical perspective, spinning up a new builder or something, like that's when we would do things like that. But yes, there is some breathing room in there, and when I put together the schedule, I knew that I was going to need it. Dexter over here.
Repeat the question. What expectations should we set for package-based documentation?
Okay, question is, what expectations should we set for package-based documentation? As good as possible. FreeBSD has a long history of being good at documentation. We have slipped a little bit in the past decade, I would say, but we have some people who are very enthusiastic, including, I see Alex in the back corner who had his hand up. I don't know if you wanted to address that question. Yes, okay. Okay, I think Dan wants to say something, and we'll get back to Alex then.
As someone who runs a lot of jails, how many of you here have used package basify to upgrade a jail to package base? I do know people on the internet who have done that, and they've reported success. So someone else try it before I do, please. Thank you.
Okay, Alex over here in the far corner.
Hey, so currently we have tried to put everything in the release upgrading doc, which is mirrored to also the installation doc, but doesn't contain installation because we've got that in the handbook. And then the main places that is in the FreeBSD base man page, which is also package base.7, but ultimately we need to either we need to fix the handbook. So currently, most of this stuff is in man package base. If you want to build the system, there's a little bit of extra stuff in build that's pertaining to package base. And then please, we're open to suggestions about how we should stagger this information. Please send it to re@ or doc@. Thanks.
Yeah, I would just to add to that, we've had a bunch of documentation sort of scattered all over the place because package base took 10 years to land, so people were writing blog posts and various web.
Maybe something along the lines of a package-based resync instead of just the package. You've got the conversion script. Maybe it can audit instead of just.
I'm not sure if that would work. I mean, if you're building from source and like you're building from, say, the next release source tree, then you're probably okay because you have exactly the same bits. I mean, the build is reproducible now, so you will have the same bits as if you just download them. If you're patching your tree, which is, I mean, that's the only reason I can see for people to build building from source. If they have their own patches they want to build, then package basify it's designed for getting the official FreeBSD packages, which would not have your patches in them.
Right, so maybe a D-package-based script then?
I'm wondering at this point if we do need to have a D-package basify to take people from a package-based system to an unpackage-based system, with a proviso that at that point you're on your own and you have to use source to update it.
I think we already do have this as package register and deregister, is it not?
Well, yeah, package gregister is the underlying command, but we could make a script that finds the right packages to deregister them, because you probably don't want to deregister all of your packages. Any more questions? In that case, I think we're done, and I will see many of you at the pub, I think.